December the 5th, 2014. For the first time in 40 years, the United States is launching a newly designed capsule for human spaceflight. This is the first test flight of the Orion space capsule, designed to become the standard vehicle for human exploration of deep space.
5, 4, 3, 2, 1. And liftoff at dawn, the dawn of Orion and a new era of American space exploration.
The American-built Orion capsule is designed to fly through space attached to a European service module providing life support and propulsion. The world's most powerful rocket will kick the spaceship into its deep space trajectory, and what is left of it will return to Earth's atmosphere. While still at the forefront of space exploration, NASA is no longer alone in the race to the red planet. Aside from the pure pursuit of scientific knowledge, there is also a strong profit motive driving the new push to explore Mars. Private company SpaceX is already employing its space capsule, Dragon, to resupply the International Space Station. And when in February 2018, Elon Musk's Falcon Heavy launched the entrepreneur's own Tesla sports car onto a course for Mars, it wasn't just a brilliant PR stunt, but also a long-term investment in space.
The most challenging test of Falcon Heavy was nothing to do with putting a Tesla on the route to Mars. It was to fly a trajectory that for 6 hours loitered in the Van Allen belts.
Doing Mars landing is one of the scariest things that I believe that we do.
It's the big step, the International Space Station, a huge worldwide project running with JAXA, with the European Space Agency, with the Russians and NASA. And now we continue. We go the next giant step in direction of Moon Mars. And that's what we do again jointly. And only in this, let's say, joint team effort, we can be successful.
The first step to interplanetary travel was getting to the Moon, which the United States and Soviet Union began working on in the 1960s, culminating with the first moonwalk in 1969.
That's one small step for man, one giant leap for mankind.
Mars exploration has been underway for decades, using orbiters, probes, and rovers. Mapping began in the early 1980s, but new imaging and information technology on the rovers and satellites has brought back hundreds of thousands of high-resolution photos, allowing for detailed 3D mapping of the Martian landscape. Building the rovers and landing them on Mars is the task of the Jet Propulsion Laboratory in Pasadena, California.
An ancient old question is, are we alone? Or are there life in other parts of the universe outside Earth? And Mars is an obvious place that we should look. Question is, did Mars have the habitable environment that I mentioned? And if it did life arise? If not, why not?
The Curiosity rover that successfully landed in a low crater on Mars called the Gale crater in 2013 is given commands from Earth by research geologist Lauren Edgar, here at the USGS Astrogeology Space Center in Flagstaff, Arizona.
One of the first pictures that we got was from the front hazard camera, so that's located on the chest of the rover, kind of looking at the foreground. And the sun was behind us, it was setting at the time. And so you could see kind of the shadow of the rover extending in front of us. And in the distance, you could see Mount Sharp, this big mountain that we had gone there to explore. So it's kind of a good perspective of this is where we are. You could see the shadow of the rover, and you could see where we were trying to get to.
We were able to show that that environment in the ancient past is very, very likely habitable. And that is a major milestone for our program. You know, we've been looking for the day to show that Mars was indeed at one time have that setting that was conducive to the emergence of or sustaining of life. We are also in the process of trying to understand what is Gale Crater, what made it that way.
The voyage to the Red Planet is fraught with immense risk. Earth and Mars rotate around the Sun at different speeds round different orbits. But even at their closest, which is every 26 months, they are 55 million kilometers away from each other. Using the technology available today, astronauts traveling to Mars face up to 9 months confinement in a small vehicle exposed to dangerous radiation from the Sun and cosmic rays. A global community of scientists and engineers is in the process of planning the first human voyage to gain first-hand insight into the geology of Mars. The editor of Spaceflight magazine, David Baker, has tracked the evolution of space exploration over 4 decades.
Well, Mars has gripped the human imagination for centuries. It's a very distinctive red object in the night sky, and it seems to have been entrenched in mythology and stories that civilizations have been attracted to and created over millennia. And really, since the advent of science fiction in the late 19th century, speculation began as astronomy increased to the point where it was possible to speculate on the atmosphere of Mars, that this is a world that could support life.
Since the last Apollo mission in 1972, the furthest humans have gone into space has been the low Earth orbit of the International Space Station, continuously occupied since the first crews arrived in 2000. For nearly 20 years, humans have conducted experiments aboard the space station, which lies outside the atmosphere but within the Earth's protective magnetosphere. While the magnetosphere acts as a precious shield against the Sun's radiation, it is also a trap for highly energized atomic particles that form 2 wide donut-shaped belts around our planet. These belts, called the Van Allen belts, are an especially dangerous place for humans.
And Earth is like a giant bar magnet of iron, because it has iron in its core. And so, like a magnet, it attracts all these radioactive particles that form the Van Allen radiation belts, and that's known as the magnetosphere. And it has a long tail on the opposite side from the Sun, which stretches all the way out as far as the distance of the Moon and beyond.
Over 2 decades, contributions from the USA, Germany, Italy, Japan, Canada, and of course Russia have turned the space station into a global village in the sky. It is only logical that the next giant steps outside the Earth's magnetosphere and beyond the Van Allen belts also be coordinated internationally.
As we go forward beyond the International Space Station, it really is going to take an international effort. There's no single country that can afford even the next step of a deep space gateway or operations around the Moon, let alone to Mars. No single company, certainly not a government on its own, can mount this unless it was a major program involving an unacceptable quantity of government funding.
But with the ISS slated for retirement in 2028, the international space community is now making bold plans for the next phase of human spaceflight. Mars is the goal, but getting a new space station deeper out in space as a stepping stone is key. Unlike the ISS, the proposed Deep Space Gateway, sometimes called the Lunar Orbiter platform, will orbit the Moon rather than Earth. Astronauts will be 1,000 times more distant from Earth than the ISS, no less than 400,000 kilometers from home. This new station, located outside the Earth's protective magnetic field, is being conceptualized and engineered in centers all over the world. Building the Deep Space Gateway and going beyond it to Mars will require massive rockets able to lift at least 20 tons of hardware, including the crew capsule, the service module, and any living quarters. While from the ISS, Earth is clearly visible through the station's cupola, astronauts on the Deep Space Gateway will see Earth as just a spot, the size of a thumbnail held at arm's length. They will be much more vulnerable to radiation in the high-energy cosmic rays. Help will be weeks away. And yet, it is still considered a safer option than flying directly to Mars.
The Deep Space Gateway, as it's called, would be a space station-like group of modules in orbit around the Moon. And it would be serviced potentially by commercial cargo lifters, much as those that now supply the International Space Station, plying back and forth once the space agencies, NASA, the European Space Agency, Roscosmos in Russia, Japan, JAXA, and the Canadian National Space Agency. And maybe China at some point will come aboard on this. But it is a program that is a consensus to create an environment like the International Space Station. So think of it as a mini space station in orbit around the Moon.
NASA's new manned spacecraft is called Orion, which is a capsule and service module combination. The European Space Agency is providing the service module, which is being made by Airbus in Germany. NASA, meanwhile, contracted with the American aerospace and defense technology giant Lockheed Martin to build the crew capsule and the Space Launch System, billed as the biggest rocket ever made. Tim Jihan is the lead space exploration architect at Lockheed Martin's Space Systems facility in Denver, Colorado.
After the retirement of the space shuttle and the successful missions of the International Space Station, the next step for NASA is to further explore deep space. First the Moon, and then going on to Mars. So Orion, the spacecraft, and the Space Launch System, the launch vehicle, has been designed to take 4 crew to do missions at the Moon and beyond. Orion and the Space Launch System, SLS, are NASA's vehicles for taking crews back into deep space.
To keep the Orion spacecraft light, the external shell is made of aluminium-lithium alloy. To protect the capsule upon re-entry to the atmosphere, it has a heat shield made of Avcoat, developed for the Apollo missions.
Orion is composed of a few different modules, and starting from the bottom, there's the adapter between Orion and the launch vehicle. Then there's the service module. The service module of Orion provides propulsion, provides electrical power, provides gases and fluids for the life support system. The service module mass is 15 metric tons, and 9 metric tons of that mass is propellant. The Orion crew module at its widest point on the heat shield is about 5.5 meters wide, and the habitable volume inside the crew module is about 9 meters cubed.
There are 5 mock-ups that have been used for testing the different phases of the mission, including one for pilot training at NASA's Johnson Space Center in Houston, Texas.
And then we get into the crew module itself, where the crew sits. That includes, again, another propulsion system for when they're re-entering the atmosphere. Includes the heat shield on the bottom of the capsule, as well as the thermal protection systems around the back of the capsule. There's computers in there, all of the life support systems, seats, displays and controls, safety equipment like a life raft, and anything else needed to keep the crew alive. And at the very top of the capsule, in the forward bay, is where all of the parachutes are for landing. And then what sits on top of the crew module for launch is the launch abort system, which can pull the crew module away from the launch vehicle in case of any problems.
Its controls are based on the touchscreen technology already being used in the Boeing 787.
So the Orion avionics and displays and controls are an evolution of commercial capabilities like in the 787 Dreamliner. So unlike the space shuttle, which had switches all over the place and behind your head, there's a very few switches on Orion, and they're all very safety critical switches. But the glass cockpit displays and the cursor control devices and joysticks allow the crew to have quite a bit of flexibility in how they command and control Orion.
NASA's Orion crew capsule will be attached to a service module being built in Europe. The skeleton of the module is being manufactured in Turin, Italy. It will then be finished at the Airbus facility in Bremen, Germany. Airbus engineers are basing the module on a tried and tested concept: the automatic transport vehicle used to resupply the International Space Station. Matthias Gronowski is the European Space Module Program Director.
The European Service Module, as part of the Orion spacecraft, there's a certain technology which we are reusing and which has been derived from ATV, from the automated transport vehicle. So what we see here is certain portion is continue life in that new spacecraft.
The basic structure of the European Service Module is built at the Thales Alenia Space Facility in Turin, northern Italy. The head of human spaceflight is Franco Fenoglio, a veteran of space engineering.
What we are doing for the European Service Module, we are basically doing the entire thermomechanical part, so the structure. And the structure, this is, I would say, more closer to a satellite structure than a module, because it's an unpressurized structure. So it's made by aluminum part, but also with a carbon fiber part, in particular in the internal panel.
What we supply with the European Service Module is we supply power to the entire spacecraft via our solar array wings. So here it's 11 kilowatt, for example, just to give you a number, we're generating for the entire vehicle. Out of the 11 kilowatt, there will be the big portion transferred to the crew module. We are delivering basically the air condition in both directions, heat and cold side.
Another pretty large part is the thermal control, which is an active thermal control. That means with pumped fluid loop, and so in the external part the heat is rejected via thermal radiators, and so mostly the entire surface of the service module is covered by body-mounted radiator.
And last but not least, we fly crew. And if you fly crew, it's important that you have water and you have all your consumables on that spacecraft. So here we need to generate the atmosphere basically in the capsule.
And the other part that we are doing also here is the so-called consumable system that include all the system for the provision of water and gases to the capsule.
After being launched by the world's biggest rocket, the capsule and service module unit will be propelled into the desired orbit by a smaller onboard rocket fueled with hydrazine.
So the propulsion subsystem of the European Service Module consists of 33 thrusters, motors in general. So there's one big motor which is a reuse from a former shuttle heritage or former shuttle area. That's a so-called orbital maneuver engine. So that's an engine which has been flown in this specific case more than 10 times.
The Orion capsule and service module unit will have its own power thrusters to control its trajectory. The pushing power is measured by the Newton, equivalent to the gravitational force on a 100-gram weight. A kilonewton is 1,000 times greater.
The main thruster is generating 27 kilonewton, and then we have several others. So the reaction control thrusters are 200 newton thrusters, and then we have the 400 newton thrusters. Those are the auxiliary, which are serving as backup. In case the main engine fails by ignition, then we are still able to bring the crew home safely by our auxiliary thrusters. The propellant we are flying is more an MMH. That's very specific configuration. We are flying here on that spacecraft on all the thrusters the same configuration, the same level of and same type of propellant.
Like all the other elements of the propulsion system, the European service module will be destroyed on re-entry into the Earth's atmosphere. But NASA and the European Space Agency plan to make deep space flight a regular event.
This portion of our contribution into the entire spacecraft will burn in the atmosphere, and by that the entire hardware is gone. But we are working on the second European service module, currently in Torino at Thales Alenia Space. So there the primary structure and the secondary structure, I guess, is being assembled.
So the next mission for Orion, Exploration Mission 1, is an uncrewed test flight of Orion out into deep space. The vehicle will go further than any human-rated spacecraft has ever gone, further than an Apollo spacecraft, and go into a high orbit around the moon for 25 to 40 days to test out all of its systems in deep space before we fly with crew. And then it will come home and re-enter and land and be recovered by the Navy. The next mission for Orion, Exploration Mission 2, will be the first crewed flight of Orion. They will be launched into a high orbit around Earth, check out all their systems, and then do a flyby around the moon and land back at Earth.
The Orion spaceship will be launched in December 2019 atop the Space Launch System rocket on an unmanned test mission. The following year, the system will be tested with 4 astronauts aboard. They will go beyond the moon. It is estimated they will spend 3 weeks in the cramped space before returning to Earth. Once the first manned flight of NASA's Orion spaceship has been completed successfully, then the voyage to the moon-orbiting Deep Space Gateway can proceed, paving the way for the mission to Mars. But in the race to the red planet, will private companies get there first? And what is motivating them?
Elon Musk in 2017 launched 18 satellites, more than any other operator in the world. And he's doing so at a cost. The average cost of one of those Falcon 9s is about $90 million. That's compared to $180 to $220 million for the conventional other rockets like Ariane and the Deltas and the Atlases, which have been used by the big mega corporations that have held a monopoly for decades.
High-tech startups like Elon Musk's SpaceX and Jeff Bezos's Blue Origin have slashed the cost of spaceflight by building reusable rockets, ones that simply return to the launch pad once used.
The exciting flight of Falcon Heavy, Elon Musk's SpaceX, that cost just under $600 million directly out of Elon Musk's bank account, because this is not a public company, it is a private company, and he put his own money into that. NASA estimates it would have cost the American government $4 billion to do what Elon Musk did with $600 million in Falcon Heavy.
February the 6th, 2018. The SpaceX Falcon Heavy shoots into space, powered by 27 Merlin cryogenic engines. It was Elon Musk's first step on the path to Mars and a public relations masterstroke. Elon Musk's Falcon Heavy wasn't only the largest rocket in the world, but its avionics package was put to the test for 6 hours in the highly disruptive and dangerous Van Allen belts.
Elon Musk knew that nobody was providing a capability that was a unique niche of what is a classified requirement from the National Reconnaissance Office and the US Defense Department for a satellite carrier that can loiter in the Van Allen radiation belts. And the most challenging test of Falcon Heavy was to fly a trajectory that for 6 hours loitered in the Van Allen belts. And the very, very survival of the avionics especially beefed up for that unique, never before achieved capability was what Elon Musk is going for, because he's offering to fly these national security payloads at a quarter the price of the big boys like United Launch Alliance, the convergence of Boeing and Lockheed Martin.
Getting all the way to the Red Planet will involve traveling through space for months. Astronauts will need a habitat during the voyage to deep space, a concept both Thales Alenia and Lockheed Martin are developing.
But right now, Lockheed Martin has study contracts from NASA to determine the design of the Lunar Gateway. And the Lunar Gateway is expected to have a few different modules, a power and propulsion element that provides electrical power, propulsion capability, consumables, communications, and a habitat where the astronauts will live and work, starting with missions of 30 days. And right now I'm sitting in Lockheed Martin's mock-up of the habitat design.
With this vehicle we are currently building, we can put on top a habitat with about 10 metric ton. That was something we can fly with our vehicle, at least in direction to the moon. If we would go to Mars, of course, we need to put something more on top, especially in terms of the propulsion system. But a habitat, that's what we are working currently on.
Most of this element of the cislunar infrastructure will have to be launched in the new space launch system of NASA, but co-manifested with Orion. That means that the mass target at launch of the payload, in this case, which is the module or the logistic cargo, etc., is reduced. So one of the key challenges is definitely the mass optimization.
The pressurized Cygnus logistics module has already been used 8 times to deliver food and supplies to the International Space Station. Building on that experience, Thales Alenia Space is now adapting the module for use as a potential habitat for astronauts in deep space. Here in the Turin plant, the company uses friction welding to bond the components together seamlessly.
All these cislunar mission will be served in terms of crew transport by Orion. Orion is a capsule that has some habitability capability inside, but the first idea for Cygnus is to use it such that it can dock to Orion and actually represent a sort of augmentation of the volume for the crew, together with the augmentation of also stowage capability, and providing maybe some sharing of functionality between Orion and Cygnus.
Making the voyage into deep space safe and comfortable is only a fraction of the massive task facing scientists and engineers plotting the course to Mars. NASA's moon missions between 1969 and 1972 marked the only time in history that humans left the Earth's protective magnetic shield and ventured beyond the Van Allen belts. Back then, they were launched into space by massive Saturn V rockets, which were cryogenic. Today, with heavier payloads, more power is needed. That extra power to get out of the atmosphere is provided by lateral solid fuel boosters.
Hydrogen and oxygen When it's as a gas, it's 30 to 40 times the volume it has when it's a liquid. So because a rocket must be contained within a reasonable size, you want to shrink those propellants down, and therefore you've got to liquefy them. A rocket motor is a heat engine. You bring propellants in to a chamber which has an exhaust outlet. You burn them in the chamber and they liberate all that energy out through the nozzle.
For long missions in deep space, whether at the Moon or at Mars, the logistics supply chain is an important consideration, particularly for propellant, which makes up a huge proportion of any space vehicle's mass. So we're looking at concepts of how to deliver propellant. And because hydrogen and oxygen is a very efficient propellant mixture and can be made from water, which is found throughout the solar system, we feel that a water-based economy being set up in deep space may be an enabler for deep space exploration. And the idea is that commercial providers would obtain water from in-space sources, or maybe just from the surface of the Earth, and deliver it to be turned into hydrogen and oxygen propellant.
Carrying liquid propellants, such as hydrazine, increases the weight of space vehicles considerably. One alternative under consideration is electric power, generated by solar panels.
Electrical propulsion system is part of our, let's say, portfolio. We implement that on satellites already. For Bremen, for the human spaceflight, for the time being, it's not part, but it will become, because that's the next step on this specific area, propulsion systems.
For cargo deliveries, solar electric propulsion, which uses electrical power from solar arrays to accelerate propellant, is a key technology. It provides very high efficiency, although very low thrust. So those cargo delivery missions would take on the order of a number of years, and that's not as great for using for crew transportation.
A new form of propulsion is under development that uses charged particles called ions to provide thrust. The first ion engines are already available.
Electric propulsion is that it is really the possibility of using a propulsion system which can keep going for weeks and months at a time and doesn't rely on conventional fuels, but essentially produces a stream of ions, and that can be provided either by solar arrays which gather electrical power from solar and convert it into a stream of ions. The other way is that you could use a small nuclear reactor.
We don't think that going to Mars requires some major breakthrough in propulsion technologies. We have the technologies today to get to Mars and back. And sure, someday if we've got nuclear thermal rockets and other interesting new developments, we'll incorporate them into architectures, but they're not necessary.
Lockheed Martin is also developing the Mars Base Camp concept, taking the Deep Space Gateway one step further.
Mars Base Camp is Lockheed Martin's vision for sending crew to Mars within about a decade. Building upon what we've learned with Orion and what we'll learn with the Lunar Gateway, it's a system that includes habitat elements, propulsion elements, large solar arrays, laboratories, to be able to go on the 3-year round trip to Mars orbit and back. Later on follow-on missions to Mars, we also have a concept for a single-stage, refuelable lander and ascent vehicle that would operate out of the orbiting Mars Base Camp and visit the surface of Mars with crew.
NASA's Jet Propulsion Laboratory in Pasadena, California, is responsible for engineering and launching the rovers. Phuc Le is the head of the Mars program and oversaw the landing of 2 rovers on the red planet's surface.
We have sent 3 orbital spacecraft from NASA, and we have sent 4 landed missions from NASA. And over this new era of exploration, we learn a lot more about Mars, how complex it is, how diverse it is. We have found very strong evidence of the presence of liquid water, again, in the ancient parts of Mars. And with Curiosity that landed about 5 years ago, one of the key questions we've been asking, in fact, probably the main driver of our robotic exploration is, was there life possible on Mars, either in the past or perhaps even today?
So if we do send future humans to Mars, we'd probably be looking at habitats that would be underground or built into a hillside so that you're partially protected from that cosmic radiation. Having any of the necessary resources. There are some places on Mars that might have some water, as subsurface ice, but right now those aren't places on Mars that we can easily land a spacecraft.
The European Space Agency is also interested in landing a rover on Mars. Close to the windswept dunes of Noordwijk in the Netherlands, the ExoMars project is specifically designed to search for signs of life on the planet. In 2016, the first ExoMars expedition was supposed to send a lander onto the Mars surface while aerobraking a massive orbiting satellite. Albert Haldeman is the European Space Agency payload manager.
The Trace Gas Orbiter TGO is the biggest spacecraft ever launched to Mars. And that's just by itself. It also had a 600 kilogram entry, descent, and landing demonstrator module on top of it when it launched. And it delivered that to Mars. It released the EDM Schiaparelli before it itself did its Mars orbit insertion. And then in the last year, TGO has been aerobraking down to its science orbit.
Unfortunately, software errors in the lander's computer guidance system caused it to crash into the Mars surface. It taught scientists a lot about the Martian atmosphere and the physics of descent.
We will take the lessons from the Schiaparelli lander that didn't succeed fully, but we got the data. In fact, we got telemetry all the way down to the ground, such as it is. And we are using that to make changes to the design we had for the lander that will carry the rover on its back.
The reasons that landing on Mars is so hard and kind of dangerous is when we enter the Martian atmosphere for Curiosity, the kinetic energy of that capsule is roughly equal to the kinetic energy that I once calculated, roughly equal to 18,000 Formula One race cars at high speed. So they're going around, as you know, the Formula One people go around at 200 miles an hour, and there are 18,000 of them. And by the time the entry, descent, landing process is finished, we have to land very gently onto the surface of Mars with the equivalent energy of a person riding on a bike.
The problem of landing actually on the surface of Mars is that there's very little help from the atmosphere because it's so thin. So parachutes need to be deployed at supersonic speed and slow down the vehicle initially as it begins to come from Mars orbit down, curving down toward the surface. Retro rockets are essential because there's no other way for terminal braking to land at a safe speed for the survival of the crew. Landing very, very big vehicles on the surface of Mars, such as that will be required for carrying people, is very problematic indeed.
This would be one of the most difficult moments of the whole mission. Between 2018 and 2020, 3 new space missions are planned with monster rockets before humans will actually go to Mars. The first launch of the SLS with an unmanned Orion capsule is due for 2019. It will be the first time a rocket has taken a capsule into deep space since 1972.
Before we put humans down on Mars, there's going to have to be several, I would suggest at least half a dozen demonstration attempts through various levels of the atmosphere. The pressure on Mars is different in summer compared to winter in that hemisphere you're coming down upon. It's different at altitude versus low altitude. One of the site selection criteria is to go, while satisfying all the scientific criteria, for the lowest possible altitude of the terrain on which you're landing to get the best bite into the densest level of atmosphere, because it pools like a fog.
If a manned mission to Mars is successful in the next decade, when the astronauts reach the Martian surface, they will see the multiple rovers sent to scout the planet first.
One of the goals of this mission was to identify habitable environments, and I think we've been successful in doing that. Obviously, it would be great to find some evidence of life, but this instrument, these instruments on this mission weren't necessarily designed to do that. So one can hope, but in the meantime, it's really fun seeing all these familiar environments present on this planet, and thinking about what it would be like to be sitting on the shores of this big lake in Gale.
Curiosity has moved over rugged terrain to reach the crest of Gale crater. Its path has taken it over rock and sand, which it has sampled and tested. Though designed to last under a year, Curiosity is still making new discoveries more than 5 years later. NASA spends billions of public monies on space exploration, but the private contractors working in the space industry pay back over and above that in taxes.
The global space budget is worth nearly $400 billion a year. Now, 78% of that is in the hands of commercial, private or shareholder-invested organizations. And the interesting thing is that the United States, NASA, spends more than half the world's total expenditure on civilian space operations. And all of that government money is less than the amount of tax that is collected from the other 78% of commercial endeavors. So American taxpayer, European taxpayer, wherever you are actually, as a taxpayer, getting a return rather than a net outflow.
Space exploration is not just about the thrill of discovery, however. The engineering and innovation breakthroughs from past space research have made a difference here on Earth. The mission to deep space and then to Mars is no different.
From what began as a space race has come a series of programs that benefits everybody on Earth. We know of the benefits from weather satellites. We know of the benefits from resource monitoring to inform us of how appalling is our husbandry of this Earth, on which we have huge responsibilities. Of the existence of an ozone layer, that we could work to legislate against fluorocarbons that were eroding it. Of the ability to put satellites into space that will help us put rescue teams with those in harm's way stranded on fog-bound mountainsides.
Already, space research is helping scientists understand more about medical disorders such as bone density loss, but also about farming in arid lands, water saving, recycling and sustainable technologies, not to mention the evolution of our own planet. Today, robotics is so far advanced that by 2020, humanoids will be able to perform so many tasks, it may be unnecessary for men and women to risk their lives on the red planet. For decades, robots have traveled over the surface of Mars, safely, undisturbed, and perfectly able to carry out the same experiments that humans can. That begs the question, why not just send more machines?
We have already begun to operate robots on the surface of the Earth from the International Space Station. When we build the Deep Space Gateway around the Moon, we will be operating lunar rovers and vehicles across the surface of the Moon from that orbiting facility, much as we do from the space station today. Robots are playing a vital role in preparing the way for humans. But there's something implicit within human nature that requires us to walk to the hill and look beyond, to look to the next hill and go to that one. It is part of curiosity. It is part of the very essence of what it is to be human.
The voyage to Mars is humanity's greatest space exploration endeavor yet. But the path forward for humans is fraught with danger and uncertainty.
Human beings have always been fascinated by that mysterious dark space outside Earth. The beginning of the colonization of space may be dated to 1957, when a first historic step took place that would mean the beginning of the space race.
In the late 1950s, 1957, the Soviet Union put an artificial satellite on top of one of their nuclear missiles, their ICBMs, and that was Sputnik, later called Sputnik 1.
Just 4 years later, in 1961, Yuri Gagarin became the first human to journey into outer space and to complete an orbital flight.
Technological progression continued so that the rockets got bigger and bigger. They were finally able to do the first moon landing on July 20th, 1969.
Neil Armstrong reached that unbelievable milestone. He was the first human ever to walk on the lunar surface. Just 2 years later, an important new step occurred in the conquest of space. In 1971, the Soviet Union launched Salyut 1, the first manned space station to orbit the Earth. It didn't take long for the United States to launch its own space station, Skylab, which orbited Earth from 1973 to 1979. The next step was the Mir space station. It was a modular space station run by the Soviet Union and later by Russia, which was assembled in orbit from 1986 to 1996. The mission ended in 2001 when it was finally deorbited. It was the first continuously inhabited long-term research space station in orbit ever. In fact, Mir could be considered a precursor to a space colony. 1998 was a key year in the adventure of space colonization. That year, the first component of the International Space Station was launched into orbit. This space station is a joint project among European, Canadian, Japanese, and Russian space agencies and NASA. It is the largest man-made object built in space to date. It has the size of a soccer field with 72 meters length and 108 meters width.
The International Space Station is a wonderful lab, and we can do a lot of science over there, and even more. We can do inspiration to people. We can raise awareness of people by the reports of the astronauts.
Since 2000, astronauts, cosmonauts, and even space tourists from 17 different nations have continuously occupied it.
The beauty of the International Space Station is not only the research done on board, but it's especially the geopolitical aspect of the International Space Station.
All of these space stations might be considered the first steps toward future space colonization, as they have proved that we really are able to survive up there in cold, dark space. Human beings have always felt the impulse to explore and discover new frontiers. From Christopher Columbus, who crossed the ocean to discover America, to Amundsen, who traveled to the South and North Poles. There have always been intrepid explorers that dared to go one step forward to see new worlds. Now, our next frontier beyond the Earth is somewhere orbiting the Earth, or on the surfaces of the Moon, Mars, or even asteroids.
Human beings have always had the destiny of flight in their minds. And over the last 100 years, we've conquered it flying on Earth, and in the next 100 years, we'll conquer it in space.
In addition to the innate curiosity that leads human beings to always go one step further, there are other reasons to find new places to colonize beyond the Earth. The first of them is that we might really have the need, in case our own planet deteriorates so much that we can no longer live on it.
Probably most important reason why we should go into space is to safeguard our own existence. Because sooner or later, here on little planet Earth, we're going to meet an unhappy end.
People like Stephen Hawking, the well-known astrophysicist, and so many others have predicted that if we don't have human settlements in space, the future of humanity on Earth is in danger.
One of the biggest hazards that humanity might face would be the impact of a large asteroid.
We have the probability that a big asteroid might hit the Earth, like it was done in the past when the dinosaurs died out.
If an asteroid were 5 miles wide, it would cause major extinctions, like the one that may have marked the end of the age of dinosaurs. There is also the possibility of a massive man-made disaster that might obligate us to leave the Earth, as climate change or industry-linked disasters. Climate change is one of the biggest menaces we are facing nowadays. In a quite short period of time, it could cause a huge humanitarian disaster affecting millions of people. On another front, overpopulation is also threatening our civilization. As a future scenario of scarcity approaches in which there won't be enough resources for the Earth's population. In such situations, having an alternative place to live could be the only way for our civilizations to survive. But there is also a huge, powerful reason that encourages human beings to go beyond the Earth. Space colonization will bring us a new, huge industry created around new resources found off the Earth. Resources in space, both in materials and energy, are enormous. And we know that, sooner or later, we will run out of resources here on Earth as they are scarce and limited.
All the resources humans need on Earth are now in space. We have the science and the technology. We know we can capture them.
The solar system alone has, according to different estimates, enough material and energy to support anywhere from several thousand to over 1 billion times that of the current Earth-based human population.
For now, a tiny fraction of the asteroid belt is more than enough to supply a virtually unlimited material for space industrialization and space colonization.
Harnessing these resources could lead to much economic development.
At some point in the next 100 years, I expect the economy in orbit will be bigger than the economy on the ground. There's more space there. There's more material that's accessible. And there's no gravity. You can do more interesting industrial processes.
The fact that we are exploiting and using expendable resources on Earth, and those resources that are out there in space, makes the obvious conclusion we have to go.
The building of a space colony would present a series of huge technological and economic challenges. A space colony would have to be self-sufficient to be able to serve thousands of humans in an environment very hostile to human beings. Depending on the location of the space colony, whether in orbit or planet-based, there are two main types. The first type would be the space habitats, or the orbital colonies.
An orbital space colony or space settlement is in orbit. So it's actually orbiting around the sun or around the Earth or around the moon in what's sometimes called free space or low Earth orbit.
The International Space Station, or the former Mir Space Station, could be considered as precursors of these orbital space habitats. A second type of colonies would be the surface-based colonies that would exist on the surfaces of planets, moons, or asteroids. Although nowadays it seems that surface-based colonies are the best option, there are, however, certain reasons to support the building of an orbital colony. A space colony in orbit around the Earth would have many important advantages over the surface-based colonies on the Moon, or on Mars, or on asteroids. The first advantage is the proximity to Earth. Travel back and forth to Earth should take only a few hours. Bringing supplies, materials, and specialized equipment from Earth to support construction would be relatively easy. In addition, there's another advantage to being close to the Earth: the protection from cosmic radiation that is provided by the Earth's magnetic field.
If you put your orbital settlement in exactly the right place, namely directly over the Earth's equator, not more than 500, 600, 700 kilometers high, you're protected by the Earth's magnetic field. And the total amount of radiation is much, much, much lower in low Earth orbit over the equator than it is on the surface of the Moon or Mars.
However, in a very high orbit around Earth, far from the protection of Earth's atmosphere and magnetosphere, or around the Moon or Mars or an asteroid, the hazard of radiation would be extremely high. Those settlers would suffer long-term exposure to dangerously high doses of radiation. Another pro of the orbital space colonies would be the continuous, ample, reliable solar energy. In a high enough orbit, there is no night. Solar power is available 24/7 in most high orbits. Although in high, low Earth orbit, there is some darkness during each orbit as a structure passes through the Earth's shadow.
Depending on what orbit you're in, you may have better access to solar energy. Not so much in low Earth orbit, but if you're in higher orbits, you have access to solar energy.
Solar panels for settlements would have to be huge in order to generate enough power. This power might be generated on separate solar power satellites and beamed to the settlement. The construction of these structures would be weightless. Zero-gravity construction means big settlements can be built with relative ease.
Some of the advantages of orbital settlement are it's a little easier to build larger things because you're operating in microgravity.
Under zero-gravity conditions, several industrial processes can be done much more easily than on Earth. Astronauts are able to move very heavy objects, up to a few tons of weight, without any help. Therefore, the lack of gravity would radically facilitate the construction of a round structure that was several miles high without its collapsing under its own weight. A near-Earth orbital colony could also generate important economic development as it encourages new energy or tourism markets. When these future orbital space settlements grow, they would be like cities in space, places where people could live and raise children. However, these orbital settlements would have several cons.
The biggest con for orbital settlement versus surface settlements is access to materials. There aren't any materials in orbit at all.
Another con would be the permanent lack of gravity, or the microgravity, that is the gravity force one experiments in low Earth orbit, as happens in the International Space Station. The lack of gravity has very negative effects on human health, such as bone and muscle loss, vision disorders, or headaches. One solution might be to build huge circular structures that spin and create at least a sense of gravity. This artificial gravity would be created using a centripetal force. In the context of a rotating space station, it would be the spacecraft hull that provides the necessary centripetal force to simulate gravity.
So it's the concept that this thing is going to be spun at a certain rate to create a sense of gravity, which again is not a real gravity. As a matter of fact, the only thing that feels gravity is a part that's pushing against the outer surface.
There are many proposed designs and concepts for orbital space colonies. However, unfortunately, as of today, no specific project has yet been developed. There is another type of space colony, the surface-based colonies that would exist on or below the surfaces of planets, moons, or asteroids. The situation regarding these is very different compared to orbital space colonies, as there are several future plans for them. In fact, in 2010, NASA approved a very ambitious program called A Journey to Mars, whose ultimate goal is to send humans to Mars in the 2030s. In addition, ESA, the European Space Agency, has an exciting concept for a future human settlement on the Moon, the Moon Village.
There are developments underway with NASA, like the Space Launch System and the Orion capsule, to put astronauts in orbit around Mars in the 2030s.
Engineers and scientists are working hard to develop the technologies astronauts will use to one day live and work on Mars and safely return home from the next giant leap for human.
The challenges of doing a human expedition are extraordinary compared to robotic expeditions. You need to launch heavy vehicles from the Earth. You need habitat in transit from the Earth to Mars. You need propulsion to speed the rate of travel up, because it takes typically 6 months. And there's a lot of radiation from galactic cosmic rays and solar flares that are just not good for astronauts that we don't know how to shield currently.
International space agencies collaborate with the commercial space industry, such as SpaceX or Blue Origin, on coordinated expansion of human presence in the solar system, with human missions to the surface of Mars as the main goal.
And lastly, what's new in space is the proof that public-private partnership works in space. When private industry has to pay some of the costs, they're much more efficient. You get the efficiency of the private sector, you get the deep pockets of the government, and you do fantastic things.
SpaceX is a very impressive company. It was founded by an entrepreneur named Elon Musk, who really wanted to break the barriers and break the mold of the things that were stopping us from getting to Mars. And this includes both high-cost space launch, but also, frankly, the timidity of bureaucracy that's unwilling to accept the kind of risks that involve to just go for it.
This collaboration between private companies such as SpaceX and public institutions will soon produce great results in the adventure of the colonization of Mars.
So these people, the Jeff Bezos, the Elon Musks of the world, are very serious about making space work for humanity and do good for humanity back here on the Earth.
Unbelievable advances in science and technology have allowed us to achieve milestones unimaginable in the past. Regarding the Moon, everything seems to indicate that we will be witness to great advances very soon. In April 2016, Johann Dietrich Warner, Director General of the European Space Agency, surprised with the announcement of an amazing concept: the Moon Village.
The Moon Village is not a project. It is an open concept with free and open access for each and everyone, be it industry, be it the public sector. It is open for robotic activities, it's open for human activities.
It is clear that in the future, humans will take part in crewed flights farther into the solar system, so the Moon Village could also act as the perfect springboard and testing ground with that objective in mind.
I believe that the Moon Village is already in its development phase, and it's only a question of a month or let's say 1 or 2 years that we really see hardware on the Moon belonging to the Moon Village.
Building and inhabiting future planet-based space colonies means a huge technological challenge, very different from orbital space colonies. Building colonies in space would require access to water, food, space, people, construction materials, energy, transportation, communications, life support, simulated gravity, radiation protection, and capital investment.
Life support for a permanent settlement, we see in the movies that there are plants up there creating oxygen and biomass and food, and you would need that.
We're going to want to set up greenhouses, and we will take the carbon dioxide that we breathe out and some of the water that we produce, and we will use it to grow plants. And they'll turn it back into oxygen and into food for the colonists to eat.
The colonies should be located near the necessary physical resources, because launching materials from Earth would be expensive. A fundamental need for the maintenance and sustainability of such space settlements would be the source of energy.
You have basically two choices at the first, which is solar energy or nuclear energy.
When it comes to think about an abundant and reliable energy that we might use in a colony in the Moon or in Mars, we first think about the solar energy.
Your energy source is the sun, this enormous fusion reactor. You can't turn it off. At Earth orbit, it's supplying you with 1.377 kilowatts per square meter continuously, forever, completely reliably.
The distance of the sun is the main problem, as Mars is further away than Earth. So light intensity is much lower, and the solar energy we could benefit from is also lower. In addition to solar arrays that would need to be on the surface, there might also be large solar power satellites that would use wireless power transmission to send power to colonies on the Moon, on Mars, or other locations in space. But in places like the Moon or Mars, solar power implies another difficulty. As the supply of solar energy is too discontinuous in these locations because the moon night is 2 Earth weeks long. And on Mars, you have an atmosphere featuring large dust storms that would cover and degrade solar panels. Therefore, one possible solution could be nuclear energy.
The problem with solar energy on Mars is that it's not completely reliable. You can have a dust storm on Mars that would greatly reduce the solar power for months at a time, which could be fatal to a colony.
But energy sources aren't the only challenge we will have to cope with. Transportation to these future planet-based colonies would be also a difficult issue. Earth's force of gravity is the main obstacle faced when transporting anything to orbit. In fact, it is often the limiting factor in space endeavors.
The cost of human exploration is dominated by the cost of launching rocket propellant from the surface of the Earth up into space.
To settle space, much cheaper launch vehicles are required, as well as a way to avoid serious pollution damage to the Earth's atmosphere from the thousands, perhaps millions, of launches required. A hypersonic spaceplane with an air intake system could be one solution. Its pollution impact would be minimum, as it doesn't use any fossil fuel, but atmospheric oxygen and liquid hydrogen to reach over 5 times the speed of sound, or Mach 5. Another possible solution to make transport easier could be space elevators.
Space elevators are an idea that came about from a Russian progenitor many years ago. The idea is very simple, that if you can erect a structure that is so tall that you don't have to have a rocket ship to carry stuff, instead carry it through a tether or an elevator to the destination.
We will probably need to transport tons of materials from the Moon, from Mars's moons, and near-Earth asteroids to construction facilities located in orbital colonies.
If we can turn the asteroids into refueling stations in space, we can dramatically drop the cost of human exploration of cislunar space, human exploration of the surface of the Moon, human exploration of asteroids, and even human exploration of Mars.
Another important issue to consider is transport within the colonies. Once we are on the surfaces of the Moon or Mars, we would need local means of transport, such as lunar rovers and Mars rovers to move around.
You need a rover to drive around, to go explore Mars. You need a spacesuit that's light enough for the heavy gravity of Mars.
Not only that, but to get around for excursions, maintenance, or safety, you would need spacesuits, as the Moon, Mars, or asteroids are hostile environments for humans.
The spacesuit people wear is a spaceship to absorb radiation and prevent changes in temperature and pressure.
To establish colonies in such distant, harsh environments as the Moon or Mars will mean overcoming many challenges. Communication for a settlement so distant from Earth would be a key factor. For settlements on the Moon and in orbit, communication is not difficult. In fact, nowadays, a great proportion of current terrestrial communications already passes through satellites. Nevertheless, for future, more distant colonies, communications become a difficult-to-solve issue. Transmissions to and from Mars suffer from significant delays due to the finitude of the speed of light and the greatly varying distance between conjunction and opposition, the closest and the furthest distance between Mars and the Earth.
To Mars, it can be as short as around 4 minutes, or as long as 20 minutes. Once in a while, if Mars goes behind the sun, you can't talk to Mars at all.
Nevertheless, future colonists would have no problem with other means of communication that do not require live interaction, such as email and voicemail systems. Any of the future colonies, whether on Mars, on the Moon, on asteroids, or an orbital space station, is going to mean coping with high levels of radiation, extreme temperatures, the lack of oxygen, and the lack of resources in general. On Earth, we have a perfect life support system supplied by a huge and complex biosphere. In space settlements, which are closed and relatively small systems, if we want to ensure a life support system, we will have to recycle or import all the nutrients to avoid its collapse. The closest terrestrial analogy to space life support is possibly that of a nuclear submarine. The challenge of mechanical life support systems in a nuclear submarine is to support humans in closed, small spaces for months without surfacing. This same technology might be employed for space use. Therefore, Building a space colony will undoubtedly be one of the biggest challenges humanity has ever faced.
An expedition that's relatively short-lived for science and then comes back to Earth, that's a little bit easier. But if you want to sustain civilization on the planet, then you have to figure out how to deal with these issues.
There is, however, still one issue without which we won't be able to survive out there: protection from radiation.
In fact, space is a seething cauldron of very dangerous radiation that comes from two sources. One is galactic cosmic radiation that comes from all directions at once, and the other is solar radiation that comes from the sun.
Cosmic radiation is a hazard. So in low Earth orbit in the International Space Station, we're largely protected by Earth's magnetic field. But as soon as you go to deep space, what's happening is there are particles coming in from the cosmos called galactic cosmic rays, and they go right through the spacecraft walls. And sometimes they collide with them into a shower of other particles, basically protons. And they go right through the flesh, and they can disrupt the DNA.
In environments with no protection to that lethal radiation like the outer space, or the moon's surface where there is no atmosphere at all, or the surface or Mars with an extremely thin atmosphere, the life would be impossible.
The surface of Mars, we've studied in many locations. It's so exposed to radiation and ultraviolet light that even organic molecules are completely destroyed.
Settlements as well as spaceships during the long journey to such distant destinations must be surrounded by sufficient water mass or other materials to absorb most incoming radiation to protect life.
So to protect you for this on a colony, you could have a safe haven. Water, I believe, is a good detector. So if you had a space colony, you could arrange, for there to be either safe rooms or the water storage could be in a strategic location.
In addition to all the challenges we have to overcome to get to our destination, there is one other that we must take into account: the effects of spaceflight on human health. If we want to go to a lunar colony, we would need to travel through space for at least 1 or 2 days with present technology. However, to go to Mars, the journey would take much longer, between 6 and 9 months. Such a long spaceflight would mean very long exposure time to cosmic radiation and to zero gravity, with the subsequent negative effects on human health. In addition to that, a mission of such long duration can carry several psychosocial problems. The solitude that astronauts suffer can generate claustrophobia and depression. In the same way, lack of sleep and monotony may affect the correct performance of tasks that in such a demanding work environment would require extreme precision. Most of the detrimental effects on the human body are related to being exposed to the lack of gravity during long space flights. There are significant adverse effects, which include muscle atrophy and deterioration of the skeleton, which is known as spaceflight osteopenia.
We know that 0G for a considerable length of time doesn't work. You end up with a lot of problems.
The top 3 complaints in space for health are headaches, backaches, and poor sleep. I believe in that order, although it's different for everybody.
Other significant effects, including a slowing of cardiovascular system functions, decreased production of red blood cells, balance disorders, eyesight disorders, and a weakening of the immune system.
You don't have the gravity pulling on your bones. So you'll lose, say, 1% of your femur, your hip bone, every month. Just gets absorbed back by your body because you're not using it as much.
And your bones start losing calcium almost immediately and continue to lose calcium throughout the flight, no matter what the duration is.
So you have several liters of fluid from your lower body that float into your upper body. And if you look at the astronauts on TV, you'll see their faces are rounder than they should be. And that's literally extra fluid that's floated from their legs into their upper body.
These effects happen in zero gravity or microgravity. But on the Moon or Mars, there would be some gravity, so consequences on human health would be different.
So the Moon has 16.6% the gravity of Earth. Mars has roughly 30% the gravity of Earth, 33% the gravity of Earth. We do not know what the human body does with this amount of gravity. We literally have no idea.
Learning to live outside the Earth will be one of humanity's greatest milestones, and it won't be an easy task at all. Engineers and scientists from all over the world are working to develop the technologies that will lead us to be able to establish our first home off Earth. In fact, there are several projects from public institutions and private companies that will kick off the future real colonization of space. Among all the colonization projects, there are some that have focused on taking advantage of using the resources on asteroids. In fact, these could be considered the first real step toward an imminent future space industrial revolution.
The asteroids are the key to an affordable program of human exploration for our civilization. So the main advantages of the asteroids for human settlements is that they allow us to engineer worlds in space that provide all of the needs for human habitation.
The first aim of the colonization of the asteroids would be the mining. Asteroid mining is a proposed industrial process in which asteroids are mined for valuable materials, as rocket propellant or certain raw materials or metals that are scarce on Earth.
We concluded that the asteroids were the best place to mine for delivering material to Earth orbit.
The asteroids right now are known to be the greatest resource of mineral resources. Economically, one asteroid could produce $1 trillion worth of revenue over a short period of time, mining it and transporting it to Earth. And there are companies seriously planning to go out and capture those. The interesting thing about the asteroids is that that kind of research can combine efforts to avoid asteroid collision with Earth. At the same time, we're mining them to get the resources for Earth.
The asteroids are a goal for space resources for two reasons. One, in terms of the energy and rocket propellant required to get there and back, they're the most accessible targets beyond low Earth orbit for humanity. Two, they have many valuable materials that can be used in space. The first valuable material that we'll harvest from asteroids are the ingredients in rocket propellant. If we can turn the asteroids into refueling stations in space, we can dramatically drop the cost of human exploration.
The main asteroid belt between the orbits of Mars and Jupiter and the so-called Jupiter Trojans, which are co-orbital with Jupiter, are the places where most of the known asteroids are located. In addition to those asteroids, there are other orbital families of asteroids with important populations, such as the near-Earth asteroids, which have orbits close to Earth. Up to date, several missions have been sent to visit some of these near-Earth asteroids. The first one to be visited by a spacecraft was asteroid 433 Eros, when NASA's Near-Earth Asteroid Rendezvous probe landed on its surface in February 2002. A second near-Earth asteroid, 25143 Itokawa, was visited in 2005 by the Hayabusa mission. of the Japan Aerospace Exploration Agency, JAXA.
So the Hayabusa mission, which was performed by JAXA, went out to the asteroid Itokawa, and they actually took a very small sample from the surface of that asteroid. It was a little less than 1 milligram of material.
The fact that asteroids are small rocks floating in space offers several advantages, but also some disadvantages. One of the greatest advantages is their low gravity because of their small size, which means an important reduction in the costs and risks of landing in comparison to the Moon's or Mars's higher gravities. This fact also makes the construction of structures much easier. The fact that there are over 300,000 asteroids identified to date is another pro, as there would be a large number of possible sites.
There are asteroids everywhere in the solar system. I mean, literally everywhere. Not every single location, but there are asteroids here and there.
It's known that there are carbon-rich, metallic, and stony asteroids. This variety in their chemical composition makes them potentially useful as materials for building or fueling spacecrafts. Material mined from asteroids could be a basis for trade economy, and precious metals may even be returned to Earth or other colonized worlds from asteroid mines for economic gain.
And with public-private partnership, we can build the infrastructure that moves industry in space, not in 20 or 50 or 100 years, but starting in 3 or 4 or 5 years. And we can be harvesting rocket propellant in less than 10 years and building the transcontinental railroad to the solar system.
Many asteroids contain large amounts of water and other volatiles, as well as carbon, all of which are necessary for life support.
The ones that we're going to be interested in first are what we call carbonaceous chondritic types. And the magic constituent that they have that we're going to be after is water.
These resources could also be transported to other places in the solar system where they are scarce, and at a much lower cost than launching such materials from larger bodies such as the Moon or Mars.
We get better space propulsion utilizing the asteroid volatile material, the water and carbon dioxide, which we can convert into rocket fuel. We'll have more mobility in space, and as that happens, we'll go further and further into the solar system. And that's the first small industrial scale mission to bring back an economically important quantity of rocket propellant that can change the economics of space.
However, to make this future mining industry a reality, we should solve several challenges, such as the asteroid's low gravity and zero atmosphere, which make them vulnerable to cosmic radiation and to the impact of small objects. There are several private companies interested in mining asteroids. On 2012, the private company Planetary Resources announced a plan to harvest resources from asteroids. The plan has a few opponents who doubt the profitability of the operation, as the cost of extracting resources like precious metals, no matter how abundant they are in the asteroids, would be much higher than its extraction cost on Earth.
There are some materials that potentially could be of use on Earth. Platinum group metals is usually mentioned. It, however, is very difficult, at least now, for asteroid mines to compete with Earth mines.
Nevertheless, Planetary Resources thinks that the plan will be profitable if they are able to develop technologies that reduce the costs of spaceflight. One way to reduce those costs would be the creation of space facilities such as propellant production plants. The asteroid mining company TransAstra is betting strongly on a plan to produce propellant using the water contained in asteroids. Molecules of water would be split into their atoms of hydrogen using solar energy.
TransAstra has a business plan that's focused on extracting rocket propellant from asteroids. You could call that asteroid mining if you want. And then using that rocket propellant to refueling stations in space to refuel NASA spacecraft and private sector spacecraft.
Another very promising asteroid mining company is Deep Space Industries, founded in 2013.
So Deep Space Industries is an asteroid mining company. We expect to be mining asteroids in somewhere in the next 6 to 10 years.
Its goal is to provide the technical resources, capabilities, and system integration required to prospect for harvest, process, manufacture, and market in-space resources.
So when we look at which asteroids that we want to mine, we're looking at several different things. We want to know that they have the materials in them that we can extract and that they're relatively easily extractable. But one of the biggest things is accessibility. They have to be relatively close to the Earth.
Nowadays, there are several projects led by public institutions and private companies, such as SpaceX, Blue Origin, or these asteroid mining companies that show that future expansion of human beings beyond the limits of our planet is not so far in the future.
We stand at a very important time in history. There have been a few important changes that have occurred in the last few years. One, for the first time we know that there's valuable water and other materials in the lunar poles and in the highly accessible asteroids that can be used to make very cost-effective rocket propellant to make it much less expensive to do deep space exploration. Two, we now have the technology to build fully reusable, very affordable spaceships. Elon Musk and Jeff Bezos are leading the way in that way. They're starting off with fully reusable rockets that launch into space. It's very obvious that the next step is fully reusable spaceships that stay in space and fly the space line. But those fully reusable spaceships in space will require rocket propellant, and we'll get that from the lunar poles and the asteroids.
We might be on the verge of witnessing a new whole revolution that will change the world as we know it now. The space colonization race has just begun.
6, 5, 4, 3, 2, 1, 0. Ignition.
The first launch of a privately owned heavy rocket ushers in a new era of deep space exploration, while volunteers across the globe are training to be the first humans to colonize a cold, rocky planet 55 million kilometers away. A place that is completely alien to humans, yet has recognizable features like canyons, craters, ice fields, dunes.
I think this curiosity that I've had since I was a little kid, it'll never go away. I always say this, I say we have this one life and it's very finite and it's short. There's two guarantees, right? Well, one is that we're born and then the second is we're gonna die. But the things that we do in between that, I mean, it's infinite. It's absolutely unfathomable what you can do with your life. So for me, this idea that we can be the first generation to create a colony off our planet and just completely start a new timeline for our history as humans is really amazing and inspirational to me.
A 6-month voyage to Mars will be nothing like anything anyone has ever experienced. You will no longer be able to communicate with Earth in real time, but probably the most significant difference with an interplanetary mission is that Earth becomes smaller and smaller in your proverbial rear view mirror when your destination is still a small dot. And it will take a very special type of person to even want to venture out under those circumstances.
For many years, there's been a big debate among scientists as to whether robots or humans should do the pioneering work in the exploration of the solar system. Now I feel we're coming to understand that it's a mission of two halves. Robots are playing a vital role in preparing the way for humans. But there's something implicit within human nature that requires us to walk to the hill and look beyond, to look to the next hill and go to that one. It is part of curiosity. It is part of the very essence of what it is to be human.
Earth, a fertile planet of plenty, 3/4 covered by water, with lush forests that make oxygen for the atmosphere. It is teeming with life, including 7 billion people who are perilously changing the natural environment. Today, people across the planet are looking to Mars as a new frontier of exploration and habitation. Nowhere is the goal as close as in California, a high-tech hub that is the 6th largest economy in the world, and where SpaceX is engineering the state-of-the-art rockets and capsules currently supplying the International Space Station. In the urban jungle of Los Angeles, 36-year-old Chinese-American actress Su An-Pian is preparing to make the ultimate sacrifice as one of 100 elite candidates selected by a private company planning to put humans on Mars.
When you're going to be one of the first test flight astronauts, there's an inherent risk, and I think you have to take that into account, that the people who want to go, you know, they're the explorers, they're the people who have always pushed our society forward, like the Vikings, or the first people that wanted to settle in the Americas. They were willing to leave everything behind, and sometimes they didn't make it, and sometimes they did. But we owe the advancement of our civilization to these forebears.
Cultural anthropologist Jack Stuster lives in nearby Santa Barbara, California. He studies humans in cramped and stressful conditions and provides recommendations to NASA about human factor psychology in deep space flight.
Living and working in a hostile environment can be very stressful. Living and working in a hostile environment in which you are confined with a small group of people can also be very stressful. And in space, you have the added stressors of the absence of gravity, the absence of access to your normal sources of gratification, your family, your friends. You can't go for a walk in the park or on the beach. You can't take your car out for a spin to blow off steam. You have to endure.
Long journeys through space present unique threats, not only to the mind, but also the human body. British astrophysicist David Baker began his career on the Apollo missions and has written over 100 books on spaceflight.
Humans, being biologically quite sophisticated and quite vulnerable, because our skeletons are on the inside, and so we're not protected from solar radiation and cosmic rays coming in from the galaxy. You are entering an environment that humans have never occupied for any extended period of time.
The unique geological features of northern Arizona, including the best preserved meteor impact crater on Earth, have for decades been considered analogues for astronauts training to go to the Moon and other planets. The nearby city of Flagstaff is a hub for scientists studying astrogeology, thanks to the complex of federally funded government labs here known as the Astrogeology Science Center. Research geologist Lauren Edgar lives on Mars every day, through the eyes of the rover Curiosity, which she commands and tracks as it explores the surface of Mars, where it landed in 2013.
We landed on ancient stream beds, so that was a great welcome to the red planet. We went there to find ancient habitable environments, and landing on stream beds was a good start. But then we only had to drive a short ways before we encountered our first ancient lake deposits. And not just was a lake present, but it had all of the right conditions necessary to support life. And to do that all within the first 6 months of the mission, that's really what we went there for. And so that was exciting to accomplish that goal early.
As science and engineering make progress, we can assume that sometime in the next 2 decades, one of the front runners in the race to Mars will actually send a manned spaceship there. What are the real risks for humans? Mars is the 4th planet from the Sun, approximately 55 million kilometers away from Earth at its closest. Spacecraft have been visiting Mars for more than 30 years, mostly reconnaissance orbiters, but also, more recently, robotic rover vehicles that actually gather soil samples, scientific data, and more than 200,000 high-resolution photos, which scientists have transformed into 3D models that they use to study the surface of Mars. Every evening, the Curiosity rover bundles its new data and sends them back to labs on Earth for scientists to process the next morning.
Every day is a discovery. You never know what you're going to find in those new images. It's what gets us up in the morning and excited to come in and see the newest image of the day.
Even just from orbiting spacecraft, scientists can see ancient floodplains, dried up lake beds, river channels, and other evidence that this cold, dry planet once had flowing liquids, possibly water, on its surface. This is especially true in Gale Crater, the place scientists have identified as the best spot for landing a potential Mars mission.
The environments that are recorded within it feel very Earth-like. These are things that look similar to stuff that we see out in Death Valley, where you have large alluvial fans that are bringing material down from the mountains. At times that it was wetter, you might have had a lake or multiple lakes that were present on the floor of this crater. Around the margins, you probably had, deltas. On the drier times, you might have had wind-blown sand dunes. And those are all very familiar environments.
Although managing a Mars rover from afar has brought humanity much closer to the planet, robots still cannot do what humans do. Scientists estimate the flight to Mars will take 6 to 9 months, one way, using known propulsion technology. With a small team of humans confined in a very small space, devoid of many of the comforts of everyday life on Earth.
I've described an expedition to Mars from a behavioral perspective as being like 4 or 5 other people and you get into a motorhome and you drive around the country for 6 months. You can't go outside. You can't even look outside because the windows are blacked out. And then you get to your destination, you get outside, you can go live in this cabin on Mars for 18 months. You get to go outside once in a while, but you have to wear a spacesuit. You're very busy while you're there. And then you get back in the motorhome for another 6 months with the same people coming home.
So on the way to exploring surfaces and worlds, we need to know and explore ourselves as human beings. Because the 3 big challenges of deep space exploration is the physical reaction, which is essentially how our bodies cope and how we as humans survive against incredibly hostile environments that we explore. The psychological response to having put ourselves far beyond Earth, and the group societal interactions that come from small, highly select, highly skilled, highly egotistical individuals.
Knowledge of how humans might live in space has greatly advanced in the last 20 years with the International Space Station. It has given the scientific community crucial clues as to what the mission to Mars might entail. The space station has been occupied by astronauts continuously since the year 2000. During that time, Many of them kept journals that are now part of a behavioral study.
For 13 years, 21 astronauts maintained personal journals for this purpose that I subjected to a systematic analysis of the content. And it allowed us to identify the factors that contribute to adjustment to the conditions and the factors that impair adjustment. The number one factor that contributes to stress among the astronauts is unrealistic schedules.
You can see here on the clock, for example, and the planning and what we need to execute on the timeline of our working day is here on this computer screen. Everything that we need to do during the day is scheduled.
Every minute of an astronaut's day is planned. But tasks that might be expected to take 15 minutes could take double that in space. So these professionals, used to accomplishing their tasks on time, find themselves constantly playing catch-up.
One of the astronauts described it this way: if you were to take a bag of M&M candies and divide them, sort them by color, put them into baggies, it would take maybe 5 minutes on Earth. That would take 30 minutes on the International Space Station, just because of the absence of gravity. And when you're in a hurry, because you're behind schedule, when you put things away, the tendency is not to take very much care in putting them away. It's a cascading sequence of unintended consequences.
The International Space Station serves as a microgravity and space environment laboratory, where astronauts do research on biology, physics, astronomy, meteorology, and other fields. Its visitors have learned how to live weightlessly, sleep in space, use the bathroom in space, get their hair cut in space, work out in space to avoid losing muscle mass. Here, astronauts learn to keep busy and control frustration during long flights. The International Space Station lies within the Earth's protective magnetosphere, which deflects the Sun's dangerous radiation, trapping highly energized particles in the so-called Van Allen belts around Earth. It is impossible to tell what the effects on humans might be when exposed to solar and cosmic radiation outside the magnetosphere. To find out, scientists have proposed an intermediate station orbiting the Moon, known as the Deep Space Gateway. This theoretical space station would act as both a staging post for Mars, but also a permanent experimental station for astronauts exploring the effects of deep space on their own bodies.
There's great attention as we come to looking at sending people into deep space, as we call it, beyond the limited altitude of the International Space Station. We know that there are going to be permanent changes that occur to the human body, and some of those are going to be neurological. Theoretically, there are some huge challenges as to what long-term effects may accrue to people spending very long periods in deep space.
There is a good case could be made for more returning to the Moon as a testing ground for a Mars expedition. And if we do that, maybe in the meantime, a more energetic propulsion method will be developed that will cut the transit time down to 2 months. And then Mars becomes a much more attractive destination.
NASA has contracted US aerospace giant Lockheed Martin to develop potential habitats for such a moon-orbiting space station. And the company is designing a habitation module for humans to go to Mars. It is based on a logistics vehicle developed to resupply the International Space Station. Tim Jihan is the lead space exploration architect in this project.
I'm standing inside Lockheed Martin's Next Step Habitat Mockup in Denver, Colorado.
We use this facility to test out different design concepts and lay out how we're going to place the items that are necessary inside the habitat. Some of the things that are here include the control center for the habitat, including the ability to control rovers or other robotics on the surface of the moon. There's also a lot of storage capability for all of the things the crew needs, food and water, things like that. If you look all the way back, you actually see the Orion spacecraft. Orion is a key part of the Lunar Gateway and provides a lot of the capability and the safety aspects needed for a long mission at the Gateway.
In Europe, the Franco-Italian company Thales Alenia has already built several transport and habitation modules for the International Space Station, under contract from private companies supplying NASA and the European Space Agency. Engineer Franco Finoglio is the head of human space projects and is working on adapting a Cygnus pressurized logistics module as a human habitat for deep space. It is a challenge to design a habitat for humans to go farther away from home than ever before.
Actually, will be the first group of people that will lose the tracking and the visibility to the Earth, because from the space station, obviously you are orbiting around the Earth, but in the moment in which you will go to Mars, you will lose this visibility. And so what this can induce in terms of a psychological effect is today still difficult to interpret.
Thales Alenia worked with astronauts to identify the top 3 design features they would like to see in future capsules. They specified these as better communal areas, more privacy, and, surprisingly, windows.
Very good. So we have full of cameras up here, and of course robotic workstation just like in the lab. And there's a beautiful Earth.
I'm sure I was not the only person who recommended a cupola because it's a great idea. And the cupola that was built in Italy and delivered to the space station is absolutely the most popular spot on the International Space Station. Astronauts spend every opportunity looking out these big 30-centimeter windows to watch the Earth below.
In the race to the red planet, private companies are working to reduce the physical and psychological risks to humans by providing habitation modules for the next giant leap into deep space. As private and public organizations from all over the world forge forward on the road to the red planet, some space engineering companies are simply adapting tried and tested concepts. Here in Turin, Franco-Italian company Thales Alenia Space has already delivered 8 Cygnus pressurized logistics vehicles for use by NASA and is developing a human habitat for future deep space employment.
One of the key points will be to understand how to change the internal accommodation with respect to what was done for the module of the space station, and then to understand which could be the improvement in terms of structure, mass optimization.
Orion is a capsule and service module combination that NASA has contracted Lockheed Martin and Airbus Defence and Space to make. It is a spaceship designed to take humans safely into deep space for decades to come. The massive rocket that will blast Orion into space is called the Space Launch System, or SLS.
Deep space is a very different environment. The radiation is higher than in low Earth orbit, and we can't use GPS in deep space because we're too high, so we need a different way to navigate. Our communication systems need to be more powerful to get back to Earth. and because the crew will be 3 or 4 days away from being back safely on their surface, the Orion spacecraft has a number of safety features built in, backups to the backups to make sure that whatever situation the crew gets in, they can get safely home.
The Orion spacecraft is composed of several different modules. At the bottom, the adapter, then the service module, which provides propulsion, power, gases and liquids, and finally the crew capsule that includes heat shield, thermal protection systems, computers and life support systems to keep the crew alive during the various phases of launch, flight and re-entry. Above the crew capsule in the forward bay are the parachutes, with the launch support system at the very top, which is capable of separating the crew capsule in case of emergency. Orion is designed to minimize the risk of human error while still providing maximum autonomy to the pilot.
With the miniaturization of avionics, the vehicle systems on Orion can be smaller and lighter and do more functions than before. But also in the deep space environment and the radiation that's there, as well as the rigors of launch and landing, Orion's computers are specially built for that purpose and tend to be bigger. Orion is designed to be either flown manually by the crew, flown manually by the ground, or be completely autonomous, or a mixture of any three. And this capability is really necessary as we go into longer and longer voyages into deep space.
While the crew capsule is under construction by Lockheed Martin near Denver, Colorado, the service module is being built by the European Space Agency at the Airbus Defence and Space site in Bremen, Germany. Matthias Gronowski is the chief engineer of the service module construction program.
In Germany we have a very large group of industry and also scientists. They would like to do really experiments on board a station, jointly together with a crew on board. So I guess it's more coming from that perspective that here we have quite significant heritage. The International Space Station, a huge worldwide project running with JAXA, with the European Space Agency, with the Russians and NASA. And now we continue. We go the next giant step in direction of Moon Mars, and that's what we do again jointly, and only in this, let's say, joint team effort we can be successful.
The first test mission to send humans out into deep space will involve spending 3 weeks in a cramped capsule, just a fraction of the 9 months estimated for going all the way to Mars. Surviving these conditions will take a very special astronaut.
The social skills that we identified from the analog research are teamwork, patience, emotional control, tolerance, affability, and confidence. And confidence is not really a skill, but it's a personality trait derived from experience.
Teams will be selected in and out completely based on their ability to function. And some of the psychological things they're going to start doing is isolation tests. Because once you go in, and I always think about this, I think it's no different than scientific teams that have to live in bases on Antarctica or in submarines. You know, you're in an enclosed small space. And we all know, you know, when you're in an enclosed small space with other humans, psychologically, that can be trying if some humans don't have the capacity to communicate or have conflict resolution abilities. And that's going to be very interesting.
Astronauts will require specific professional skills to function as individuals in a team, and those skills have been identified in Jack Stuster's research.
The pilot needs reaction time, spatial orientation, rate control and control precision, all these kinds of tasks, all these skills that are needed by pilots to land aircraft safely. The others, the leader, the biologist, geologist, mechanic and electrician, IT specialist, all rated inductive reasoning, deductive reasoning, problem sensitivity, information ordering, and all these problem-solving abilities as the highest in their fields.
Conditions during a flight lasting many months will be a challenge. Instead of showering, astronauts will use wet wipes. Freeze-dried and canned food is all there will be to eat. 3 hours of exercise is required every day to maintain muscle mass in the zero-gravity environment. There will be constant noise on the flight, and each astronaut will have less than 20 square meters of living space. The danger and discomfort, however, does not seem to deter Su An Pien from her dream of deep space flight. She even jokes about being the first to ever take a selfie on Mars.
If you think about a citizen of the planet, you know, if you get off planet, your perspective starts to change. And you start to see that we're actually one globe, and we need to learn to work together in a unified way. And it doesn't matter where you're from, if you're Chinese, American, Italian, Russian. At the end of the day, how we interact with one another, when you change the perspective, it shows that we're one.
There are certain lessons for getting along in space, such as think about what you're going to say or do before you say or do it. This is especially important when you might be reacting to something, when an astronaut might be reacting to something, an issue, knowing that trivial issues are exaggerated. Put your stuff away. Don't leave things around. Don't leave your laptop open on the workstation. Don't put away the materials that you used for a previous task. Most important is try not to be annoying in any way.
Actually getting to Mars is fraught not only with threats to the human body and mind, but also with engineering difficulties that will have a bearing on the survival of the elite team that is eventually sent. However, the spectacular launch of Falcon Heavy showed that some of that technology is already available. The young entrepreneur Elon Musk is a visionary who has made big promises.
A few years ago, we didn't have a rocket that's capable of doing what SpaceX is now able to do in terms of bringing massive cargo and eventually people. You know, Elon Musk wants to bring 1 million people on Mars and create a Martian city at one point, and he's not joking around, and he's advancing at a really quick pace. So, you know, the things that we got to do right now, we have to be able to work in teams, I think. I think it's not anymore about a competitiveness of who's going to be the first. It's going to be, well, here's what we can create. We can give you the first teams that are trained, you know, over 10 years of humans that can absolutely live and survive on Mars.
If a crew does land and finds that previous robotic missions have created a shelter, what will life be like for the small group?
In terms of getting people to live on the red planet, there's still a long ways to go. So what we're looking at right now, I know Mars One actually contracted with Paragon to create the first life support system, as well as a Martian suit that could withstand the radiation and the different temperature variations and fluctuations and atmospheric changes that needs to happen once people are there. That being said, technology is moving at a rapid pace.
Selecting a crew for the first few expeditions to Mars, human expeditions to Mars, is going to be very difficult. We will identify their occupational specialties. We'll identify the abilities and social abilities, skills needed. But when it comes time to actually selecting the crew, all of that will probably get put aside, and it will be the Russians get to select, the Americans get to select, the Europeans get to select, the Japanese will probably get to select, and who knows if maybe the Chinese will be involved by that time. And So it will really probably boil down to training.
Assuming that the technical problems of getting to Mars are solved in the next 2 decades, and our knowledge of Mars improves enough to be able to plan a manned mission in detail, someone will soon be setting foot on the red planet. Surviving on Mars will be the biggest challenge facing the first humans to land there. While space capsules and habitats will have been tried and tested before they leave, the Mars soil, known on Earth as regolith, and the atmosphere are both toxic to humans.
Obviously, there's issues with not having enough oxygen on the surface. So you'd be supplying your own. The radiation environment is really harsh. So if we do send future humans to Mars, we'd probably be looking at habitats that would be underground or built into a hillside so that you're partially protected from that cosmic radiation. Having any of the necessary resources. There are some places on Mars that might have some water. As subsurface ice, but right now those aren't places on Mars that we can easily land a spacecraft.
The biggest risk is from charged particles, solar events, because there is no protection of the crew in transit for the 6 months going to Mars or the 6 months coming back, or when they're on the surface of Mars. That's why the habitat that will be built, that will be positioned in advance of the crew, must be covered with something. A meter of Martian regolith would help, but something has to be done to shield the humans on the surface of Mars from radiation.
Once I enter my 40s, the risks on my body in terms of radiation lower significantly. So to me, I'm like, it's going to be all right,
Lockheed Martin is planning to create an orbiting base camp, avoiding the need for humans to actually live on Mars.
Mars Base Camp is Lockheed Martin's vision for sending crew to Mars within about a decade. It's a system that includes habitat elements, propulsion elements, large solar arrays, laboratories. The Mars Base Camp lander and ascent vehicle is a key piece of technology to enable us getting to the surface of Mars in later missions. And in having it being able to be reusable and using aerodynamics to slow down and supersonic retro propulsion, that allows us to visit multiple places on the surface of Mars and bring scientists, astronauts to those locations to explore the surface of Mars.
Wherever these astronauts actually live, they will be confined for months on end, even years, in a tiny and dangerous space. In most hypothetical scenarios, Mars astronauts land on the planet to find habitation modules already deployed. They will have to work hard, however, to turn this barren land into anything hospitable. The presence of water will be essential for success. The rovers roaming the surface of the red planet today are providing new clues about the geology and topography of Mars and the water present on it, which scientists hope might one day be able to be utilized to farm and support human life.
We can't all of a sudden get a well and look into a lovely pool of water that's gushed up from beneath the surface. So you would have to contain it in an atmosphere contained within a device, a structure that would enable the temperatures to be increased and the pressures to be increased so that it could be retained as liquid water.
Once the astronauts are on Mars, and the next opportunity to launch back into space and return to Earth arises, they will have had to synthesize fuel for their launch vehicle to return home. Probably the biggest single advantage derived from travel to Mars is the advancement of related technology on Earth. The billions spent so far on Mars research could help solve problems on Earth with its dwindling resources and ominous climate change. The field of medicine is a promising area for space spin-off research that could have a positive impact on our daily lives. Here at the University of Nice, Yassine Ben Youssef is the CEO of the French startup SpaceMedX. He is testing new systems for rehabilitating stroke victims. The technology is based on a weightlessness simulator built by Mars Planet in Italy.
This is our laboratory in partnership with the LAMES at the University of Nice. The multigravity was put here to make some trial and to evaluate the work pattern in hypergravity. So how it works, you can go inside, attach that piece of metal with the harness and this circle for safety, and you go on the platform, the treadmill, and the form of the treadmill allow you to walk and to stay at your place. And with cameras and some sensors, you can use virtual reality and stay at the same place walking in a virtual environment, like in the Mars habitat on the moon.
The system is tested here with a sports medicine lecturer. She is able now to walk in a simulated, weightless environment.
On the screen, you can see like marker. So we put some marker on the subject to specific point, like this on the foot. And after that, with all the camera around the system, we can capture the coordinate of each marker. And when we're moving, we can see the people moving. And after that, we can measure all the joint angle, like the knee, the foot and the hip. And the objective of the project is to compare walking on treadmill and walking on the multigravity to see if the kinematics, so the joint angle, is similar. And finally, we can put them on rehabilitation program to see if we can, like using the hypogravity to get normal walking pattern.
When we go into space, we take upon ourselves all of the conditions that occur in the aging process to humans on the surface of Earth. We have loss of bone mineral. We increase the amount of fluid in the body. We get that in old age. But in addition, we change the red cell blood count as well, which makes us less resilient against disease and against infection. All the organs lift. Our spine stretches 1 or 2 or 3 centimeters. We change the way in which our brains actually process information because it begins to impress upon the cranial cavity.
Finding solutions to the typical side effects that come from prolonged periods in space, such as the weakening of bones, could have enormous socio-economic advantages on Earth, where the aging population suffers from bone density loss and osteoporosis.
The great advantage of humans in space is that they are making a unique contribution to the database and the support for the care of the elderly on Earth. This is a great, big, unsaid truth about space medicine. And there are universities around the world working with what is considered to be the biggest collection of human physiological data on the surface of the Earth, that held by NASA and the US Air Force School of Aerospace Medicine.
We've pretty much solved muscle atrophy by vigorous exercise. They're working on bone demineralization, and they're working on pharmaceutical type mitigations. And when that is solved, which it must be solved before we can go to send humans to Mars, it will change everything on Earth. Imagine not having to worry about a broken hip as you grow old. That will be probably the biggest spin-off of NASA technology. The cost to society each year for broken hips in North America is $45 billion. That's more than twice NASA's annual budget.
Suan Pien is fully aware of the risks to her body, but she is not deterred. She sings and dances her way across the Earth's stage. On Mars, she'll be lucky to survive.
You have to make sure that you're in a certain level of health. You know, we watched Scott Kelly go around the globe, and when he came back, there was definitely issues about his eyesight, and I think there's a lot we don't know yet about how space can affect us. We're pushing the levels of human adaptability, right? And we were talking about phenotypes and how human phenotypes can change based on the environment. Now, if you think about a human that eventually goes to Mars, where the gravity is a third less, you're going to look at humans that are going to be taller and skinnier eventually, and we're going to adapt in very different ways.
The dreamers may hope that one day humankind will set foot on Mars. But the sheer distances and the real threats to the bodies and minds of humans undertaking that voyage seem nearly insurmountable. But are there more urgent uses for the monster rockets being built to fly into deep space?
There are these other destinations, the asteroids, that really we should be looking into. You're probably aware that every month a new asteroid is discovered that passes between the orbit of the Moon and Earth. We need to learn more about asteroids and their composition in order to develop means for defending Earth from something that is really a serious risk. I've said, Mars attracts our attention, but the asteroids demand it.
The race to the red planet will certainly lead to exciting extraterrestrial discoveries, but will also vastly expand what we know about our own planet and our own biology.
You can explore challenges to current knowledge, and you can push on the frontiers of human understanding and roll back the mists of ignorance and uncertainty and discover new things. That is implicit within the human condition. It is why we want to explore.
Humanity is exploring the universe faster and further than ever before. But is it safe? Can people survive on Mars? The rovers and orbiters we send for reconnaissance can tell us a lot about the red planet. But only landing humans there will...
The Moon. The brightest and largest object in the night sky. It is the closest large body to Earth in the solar system, at a distance of only 239,000 miles. The Moon is the only celestial body on which humans have set foot. Exploration of the lunar surface by spacecraft began in 1959 with the Soviet Union's Lunar program. Luna 1 failed to land on the Moon. However, Luna 2 did succeed in landing, becoming the first artificial object ever on an extraterrestrial body. Several unmanned lunar probes followed those pioneering missions during the following 10 years. Just a few years later, in 1969, a great milestone was reached. The Apollo 11 lunar module landed 2 astronauts on the Moon. For the first time ever, a human being walked on a celestial body besides Earth.
That's one small step for man, one giant leap for mankind.
Since then, 12 others stepped on the Moon in the different Apollo missions. The last one, Apollo 17, was launched in 1972. It marked the end of the Apollo lunar mission. After that, for several decades, the Moon as a priority target disappeared from the programs of space agencies, and human beings didn't walk on the Moon again. Given the fact that it's so close to Earth, and considering our interest in exploring space, why didn't we go back to the Moon?
This was in a totally different time than we are today. This was in the time of race in space. It was about prestige. It was about showing the power and the possibilities a nation has.
Nevertheless, in 2009, something happened that changed everything and encouraged space agencies and private companies to start once again to develop manned missions to the moon after so many decades of lack of interest. That year, the Indian Space Research Organization's Chandrayaan-1 probe made a surprising discovery that put the moon in the spotlight. It discovered the widespread presence of water molecules in the lunar soil, overturning theories that had stood for 40 years.
The Chandrayaan-1 mission was a very special turning point in the exploration of the moon.
Some of the payloads on that mission conclusively verified the presence of water ice. Just 2 months after that, in November 2009, NASA reconfirmed water on the moon with its Lunar Crater Observation and Sensing Satellite Space Probe, which detected large quantities of water ice.
We are talking about scooping something, melting it, and water. You know, that makes a big difference to get water that you can drink, that you can live by, water. The Indian mission clearly showed a sign of water, not as composites of minerals or anything like that, just water.
In March 2010, it was reported that the Minisar on board Chandrayaan-1 had discovered more than 40 permanently darkened craters near the moon's north pole that are speculated to contain an estimated 600 million metric tons of water ice.
This was quite revealing because for about 30 or 40 years, there's been debate. There's been a growing debate about, is there water on our moon?
If future research finds large enough quantities of water ice, it could be turned into liquid water for drinking and plant irrigation. It could also be split into hydrogen and oxygen with the energy provided by solar panels or a nuclear generator. The hydrogen might be used as rocket propellant and the oxygen for breathing.
NASA now, after the Chandrayaan-1 mission, they've gained the support to put together a mission to go to the surface of the moon. They're going to put a rover on the moon that has the ability to scoop the material and examine it. And I think that will convince everybody that there's a lot of water on the moon.
Nowadays, thanks to this discovery, human beings are thinking of going back to the moon again after many years. In fact, the moon might become our first space colony in the near future. We have the technology and the know-how we need to do it. But what drives human beings to consider settling a colony beyond the Earth? There are several reasons that lead us to suppose that, sooner rather than later, human beings will go beyond the boundaries of the Earth to settle somewhere in the solar system.
We've done this everywhere on this planet. We've colonized every place that we could possibly colonize on this planet. So it's a kind of genetic thing.
The rise in population is causing an increasing need for resources. The Earth is becoming too small for so many inhabitants.
Population on Earth has become a controversial problem now for a long time, starting with the limits to growth movement.
We need to find more raw materials to support our whole population and so that civilization could keep on progressing. Those resources are out there.
There's enough material in the asteroid belt to build beautiful space colonies with a total land area 1,000 times that, the surface of the Earth. A habitable volume capable of sustaining a human population of 1 trillion people, which gives us the promise of humanity expanding, growing, and thriving for at least another 1,000 years.
On the other hand, there are hazards now that lead us to think that we may have to leave the Earth someday. climate change has become one of the greatest dangers humanity has ever faced, and could lead civilization as we know it to its destruction if we don't stop it in time.
We should do exploration because it's in our genes to be curious, but at the same time we should save our planet as much as we can, and through exploration we can learn about our planet.
Undoubtedly, there is in human beings an internal impulse that makes them explore new frontiers. Now, our next step could be the moon. The discovery of water there, an indispensable element for life, was the key factor that lets us consider our satellite as a possible future home. However, the moon is not a hospitable place for human beings. So the challenges that we all have to face to settle a colony there are very great. Despite its proximity, the moon has characteristics that make it a very different place from our planet. First of all, its diurnal period is very different from Earth's.
It depends where you are on the moon, the length of day. If you go to the poles, your day can last most of the year because you're in almost permanent illumination. If you go down to the equator, then you get about 2 weeks. So you know that you've got about 2 weeks of day and then you've got about 2 weeks of night. So it would be a completely different way of living, and you'd probably have to artificially create day and night.
Its gravity is also different from Earth's. While we have a gravity of 1g here, on the moon, it's just 1/6, 6 times less than on Earth. As of today, we don't yet know exactly how this lower gravity could affect human health in the long term. We know that exposure to weightlessness over month-long periods cause deterioration of physiological systems, such as loss of bone and muscle mass and a depressed immune system. Similar effects could occur in a low-gravity environment as the moon's, although it is still unknown.
The moon has 16.6% the gravity of Earth. Mars has roughly 30% the gravity of Earth, 33% the gravity of Earth. We do not know what the human body does with this amount of gravity. We literally have no idea. Is it more like having 1g, full gravity, or is it more like having null gravity? We actually don't know. We presume it's a spectrum, that the moon is more like having no gravity than Mars is. Mars is more like having full gravity than the moon is. Those are just sets of assumptions we've made, but we actually have no idea.
Temperatures on the moon, as well, are also completely different from the Earth's, which would condition certain aspects in the functioning of the colony.
You get a temperature swing of several hundred degrees between lunar night and lunar day. The temperature difference is so great, it actually triggers seismic activity.
The frequency and duration of seismic activity on the moon is such that it becomes a serious hazard to the integrity of a permanent base on the moon.
There are a group of moonquakes called shallow moonquakes, and some of these reach magnitude 5 or above. And in terms of Earth, that's reasonable. But when the moon has a seismic event, it keeps on going. It doesn't just last 30 seconds to a minute. The maximum ground motion lasts 10 minutes.
Another of the characteristics that might affect a lunar base is that, unlike the Earth, the moon has no atmosphere to protect us from radiation and other dangers.
Not having an atmosphere on the moon affects several things. First, again, is safety from micrometeorite impact. It comes in faster than a bullet, and you don't want to be in the way of that.
It also leaves the lunar surface exposed to half as much radiation as in interplanetary space, raising the issues of the health threat from cosmic rays and the risk of proton exposure from the solar wind. Apart from that, it's known that the presence of volatile elements on the moon, such as nitrogen and hydrogen, is extremely low. If we are not able to recover these volatile elements, they will need to be imported and recycled for life support in industrial processes. Unfortunately, this fact would serve to limit the growth of the future colony, as it would be dependent on imports. Despite all this, the proximity of the moon offers several advantages that make it the most obvious natural expansion after Earth. The duration of the journey to the moon is short. In fact, the transit time of the Apollo missions was just 3 days. In the near future, the technology will allow us to reduce it greatly. This short transit time would also be useful in case of emergencies, whether to send emergency supplies to the moon or to evacuate a human crew back to Earth.
The moon is a very interesting body. It is close to us. You can reach it in 1 week. You can go to the moon and back if you like.
The short distance causes a communication delay to Earth of less than 3 seconds. So voice and video conversations would be almost in real time and allow Earth-based teleoperation to be a viable alternative to robotics and local human operation, which is not possible on any other planet. The fact that a settler would always see the Earth as a large and much brighter object than the moon appears from Earth would mitigate the sensation of loneliness that those settlers might feel. The moon's lower gravity makes it much easier to launch rockets from the moon, as they would need much less energy than needed to escape from Earth's much higher gravity. Therefore, a lunar base could be a much better location for launching rockets to other planets, such as Mars, using locally manufactured fuel. All these advantages lead many people to see the moon as the most feasible target for a future colony off Earth. Other goals, like Mars or even the asteroids, also have ongoing projects and studies. Private companies like SpaceX and Blue Origin and public institutions like NASA are developing projects to soon colonize Mars.
There are developments underway with NASA, like the Space Launch System and the Orion capsule, to put astronauts in orbit around Mars in the 2030s.
Engineers and scientists from all over the world are working toward a new era of manned space exploration.
The moon can be a stepping stone. The moon can be something like learning also logistics. The moon has scientific value, and maybe also for tourists the moon is of interest because you can really do it in summer vacation. And therefore the moon is something also like a stepping stone to go, for instance, to Mars, but it is also an interesting destination by itself.
Its proximity and its special characteristics mean we can consider the moon a good place to settle, and it might become the starting point for unprecedented space industrial development. When it comes to colonizing the moon, one of the key points would be to decide where exactly to settle the colony. The chosen place will largely determine the functioning of the future colony. The potential locations fall into 3 broad categories: the polar regions, the equatorial regions, and the far side.
That is the main debate. Where do you go on the moon? Currently, we have mapped the entire moon and in very high detail, and we have looked at minerals and the availability of resources all over the moon. We think that the polar regions are probably more promising because there's water in those regions, readily accessible water. And water is the source of life, and if you can find water, if you have water, a lot of other things become easy to do. The polar regions of the moon also have constant sunshine. And that gives you energy, and you have water, and then you can have a permanent colony there.
Another location for a lunar base could be the lunar equatorial regions. They are likely to have higher concentrations of helium-3, rare on Earth, but much sought after for use in nuclear fusion research.
We have on Earth a very favorable situation that we have a lot of resources on Earth, all types of elements. But some of the elements are rare, and some of these elements you can find in our solar system, in asteroids or on the moon. So helium-3 is one of them mentioned, but I learned from scientists that up to now, to produce helium-3 on Earth is cheaper than to get it back from the moon.
Equatorial regions also enjoy an advantage in extra lunar traffic for launching material, as these regions coincide with the lunar orbit around Earth and nearly coincides with the equatorial plane of Earth.
Now we know that if you send a rocket ship from the Earth to the moon, there are certain trajectories called free return trajectories. That is, you don't have to put so much energy to be able to come around. Once you fly out to the moon, you go to the moon and you swing, the moon swings you back to Earth.
However, the great disadvantage of equatorial regions is that they have 2 continuous weeks of night.
That's not viable for us, because if we don't have light, we immediately have a problem with storage of power. And if you are in the dark for 2 weeks, that is very hard on a lot of systems. Engineering, tools, instruments, they all freeze.
On the other hand, the fact that the lunar far side is well shielded from Earth makes it a good location for a large radio telescope. The site would be also interesting for an array of optical telescopes because the moon also has no atmosphere.
If you go to the far side of the moon, you have the advantage you are in the shadow of the moon concerning our radiation coming from Earth. You have a stable surface, so you can build a huge installation using moon material, and then you can have a deep view to the universe, and therefore to go on the far side on the moon with a radio telescope is for scientists already a very impressive and inspiring activity.
Once we have selected the best location for a lunar base, the next step would be to consider where and how to build to protect from radiation, meteorites, and other possible dangers.
If you're on the surface, you're exposed to solar particle radiation, which is dangerous for our physiology. The temperature extremes, that can be 300 degrees centigrade between the dark and the light. And you also have micrometeorites, which are much faster than speeding bullets, and they shower.
If we want to have astronauts over there, then we have to do something for radiation shielding. There are lava tubes on the moon. Why not using these lava tubes?
The lava tubes on the moon could be a good location for a settlement, as it would be protected from the severe hazards of the lunar surface, such as frequent meteorite impacts, cosmic radiation, and extreme temperature variations.
A lunar lava tube is an old form of flow. It starts on the surface, we see it on Hawaii. The surface solidifies, forms a crust, and the magma keeps flowing beneath that, forms an underground river. As the amount of magma wanes, the eruption dies down, that drains down and leaves a void.
They also have proven themselves as a reliable structure, having withstood the test of time for billions of years.
More importantly, we believe the thermodynamics makes us think that the interior has a steady temperature of about minus 20 degrees Celsius.
All those reasons lead us to think that the first permanent settlement on the moon could be underground. We would be protected from cosmic rays, from solar storms, extreme temperatures, and also from being hit by meteorites.
We also think that once you settle underground, you should not get the feeling that we're going to be there all the time. We would go out and do the science and tourism. The symbolism is clear. When humans started to evolve, we were cavemen. We lived in natural shelters. And it's interesting to me that you'd fly down to a new planet or to our moon, and the first home would be an astronaut caveman. But we have to learn to live outside. I think it's like growing up to be a real people. And so over time, I think we'll probably live on the surface of the moon and other planets.
A possible solution would be to construct a lunar base on the surface and cover it with lunar soil or lunar regolith, composed of rock and mineral fragments from underlying lunar bedrock broken apart by the impact of meteorites.
Well, regolith is loose material. It is often mistermed soil. Soil on this planet has organic matter in, and we know the moon does not have that. So it's loose material, loose sediment on the surface that has been formed through meteoroid impact over millennia.
Lunar regolith is composed of a unique blend of silica and iron-containing compounds that may be fused into a glass-like solid using microwave energy.
The regolith can be used as a building material because it can actually manipulate it. You can move it with the dust that gets kicked up with the lunar rover when the astronauts are up there. So you can use a backhoe, if you like, to move it around. So it's one of these features that you can pile up, you can tunnel into, you can mine it, so to speak, but you can use it as a building material. One thing we've learned is that this regolith contains very small particles of metallic iron, and that couples very well with microwaves. So you can actually melt lunar regolith in a kitchen microwave, and so you can sinter that to make it solid, at least a solid surface to cut down dust, but also to make bricks for construction.
Once we know the location, it's time to think about how to construct our first lunar base. As technology and our knowledge of the moon have advanced in the last few years, the design of lunar habitat proposals has also evolved. Concepts vary from the adaptation of landers or their used fuel tanks as habitats to different inflatable modules.
We should have what we call, in our jargon, pre-integrated structures, which are really large spacecraft with everything in it already. You touch down and you turn on the light, you have your office. That's your site office.
One of the greatest obstacles we have found to building on the surface of the moon is the dust.
Lunar dust is very, very difficult. Lunar dust is microns in diameter, made over billions of years of these micrometeorite impacts on the moon that geologists call gardening. It's called gardening, it's a geological phenomenon. And so when this powder is charged by the solar wind, it becomes electrostatically active. So when you wear a nice astronaut garment and step out on the lunar soil, the dust climbs up into your body. It goes between the seals of your gloves and it scratches your visors. And just a few minutes after any kind of work on the lunar surface, your suit is completely smudged. The thermodynamics is completely messed up. You start to have problems because you cannot see. And so dust is a problem. NASA knows this because of Apollo. So my idea was that you would build a complete lunar base in Earth orbit near the space station, because it's outside of Earth and there's no gravity, completely assemble it and fly it as a fully pre-integrated, prefabricated structure, land it on the moon, and you have your habitat.
One of the most interesting ideas is the use of 3D printing technology to build lunar habitats. One of these 3D printing techniques is contour crafting.
There is a technique of building robotically called contour crafting. We can use raw materials from the moon, especially moon dust. We take moon dust, mix it with sulfur or some other compound to bind, and then we compress it like toothpaste and build walls. You can easily build any shape and erect structures using robotic technologies. And you can do this from planet Earth. You don't have to go to the moon to do this. So some of us believe that we can look at what is happening on the moon from Earth and build up structures to such a point that once the basic structure is built, then we can send people there to put things inside the structure.
In addition to contour crafting, another 3D printing concept is one proposed by architectural firm Foster & Partners. These 3D printers would use raw materials from lunar regolith to cover enclosed inflatable habitats for housing the human settlers, which would provide both radiation and temperature insulation. One of the greatest advantages of these techniques is that just 10% of materials for the structure mass would need to be transported, as 90% of it would be local lunar materials.
So we think by doing 3D printing activities and robotic construction technologies, introducing them, we can keep astronauts safe while work is being done. 3D printing has become an established way in a lot of robotic activities, particularly in the building industry.
Therefore, there might be several different types of colonies for the moon. Underground excavated colonies, or inside lava tubes, or on the surface. But all of them have something in common. They all need a source of energy. There are several options when it comes to a source of power for a future lunar base.
If you want to stay on Moon, either with robotics or with humans, you need, of course, energy. You need, most probably, you need electric energy. And there are different possibilities how you can get the electric energy. You can do it with nuclear, you can do it with solar energy, but the simplest is, of course, solar energy because it's free of charge and you do not have to have a big maintenance.
If we want to produce solar panels on the moon, we could extract many of the raw materials on site. The main difficulty for the use of solar power would be the long lunar night of almost 15 days. One possible solution might be to build several solar power plants so that sunlight would always reach at least one of them.
The source of energy for any permanent moon base is going to be critical. And solar is I would say, the easiest option. There's been lots of talks about nuclear fission reactors, but trying to get a nuclear fission reactor to the moon is a bit expensive and a lot of paperwork involved. But also the fact that you don't have any clouds up on the moon, so when it's daytime, you've got guaranteed 100% energy. Solar energy is the best option.
Another possibility would be the construction of a power plant in an area of constant or near constant sunlight, such as the South or North Poles. A third option would be to use space solar panels in orbit and beam the power down as microwaves. Nuclear fission could be another possible source of energy on the moon. With just one nuclear fission reactor, we could supply the energy requirements of a lunar base. And the handicap of the 354-hour lunar night wouldn't be a problem at all. whether it be solar or nuclear energy that is used, how would it be stored?
Energy storage has been a problem on this planet, but right now it would have to be batteries. It'd have to be either hydrogen fuel cells or just regular batteries. And some of the missions I've looked at, which are robotic missions, we've looked at using solar and then using batteries to survive the lunar night. And batteries are heavy, so it adds mass to your mission, and therefore it adds expense to your mission. So understanding good energy storage is an area of research that really needs to be done.
At the beginning, energy would be provided by a combination of solar panels for daytime and fuel cells for nighttime. Fuel cells have operated on the space shuttle for up to 17 Earth days, so their duration would be enough for the 354 hours, almost 15 days, the length of the long lunar night. To have the supply of a source of energy is a key requirement to settle a colony. But in addition to a reliable source of energy, there is also something vital to making a lunar base feasible: a life support system.
The next step in going back to the moon and beyond is ensuring that we make use of the resources that are available on the moon. And that includes creating life support from the volatile deposits, hydrogen and oxygen and water.
A life support system must be able to sustain humans living in space, allowing them to survive there. It may supply water and food, as well as include monitoring atmospheric pressure, oxygen levels, waste management, and maintenance of correct body temperature.
Life support for a permanent settlement, we see in the movies that there are plants up there creating oxygen and biomass and food, and you would need that. It's been shown from the Apollo regolith that the plants can be grown in it. There's no harmful side effects from growing plant in regolith. The one thing that will be needed is organic matter, because the regolith doesn't contain any.
However, if we want to grow crops on the moon, we will have to overcome difficulties such as extreme temperature variation on the surface, exposure to solar flares, the long lunar night of almost 15 days, and lack of insects for pollination. The fact that the moon has no atmosphere implies that we would need sealed chambers to grow plants there, which wouldn't be a problem, as it has been proved that plants can thrive at pressures much lower than those on Earth. One of the main issues with lunar agriculture would be the long lunar night. As the use of artificial light would mean high energy consumption, other sorts of solutions are being considered, such as the use of fast-growing crops that might be started as seedlings with artificial light and be harvestable at the end of one lunar day. When it comes to settling a permanent lunar base, another fundamental need is transport. The moon's distance from Earth is about 239,000 miles. So, one of the first obstacles that must be solved would be to develop a simple means of transport to get there. In addition, a transport system to get around on the surface of the moon will also have to be developed. For the journey from the Earth to the Moon, conventional rockets have been used for lunar explorations to date. Another proposed concept of Earth-to-Moon transportation are space elevators. This technology would take advantage of the fact that the Moon's gravity is much lower than the Earth's.
The idea is very simple, that if you can erect a structure that is so tall that you don't have to have a rocket ship to carry stuff, instead carry it through a tether or an elevator to the destination.
When it comes to the transportation on the lunar surface, proposed concepts include a variety of vehicle designs, from small open rovers to large pressurized modules with lab equipment, and also a few flying or hopping vehicles. For a colony to be considered a colony and to be sustainable in the long term, it has to be nearly self-sufficient. The colonization of the moon could offer interesting business opportunities, as it could be a place for companies to develop products and services, such as a future lunar mining industry. Mining the moon's materials on-site for use both on the moon and elsewhere in the solar system where they might be needed in the future would greatly reduce costs compared to sending them from the Earth, as much less energy would be required to launch them into space.
The kind of things that we would like to see are, of course, a commercial mining infrastructure on the moon and a fuel depot associated with the Deep Space Gateway. It will only enable a trip to Mars if you can store fuel and resources in the vicinity of the Deep Space Gateway.
As the mining business in space develops during this century and human beings become a multiplanetary species, large amounts of matter will need to be launched to several locations in the solar system. Therefore, the moon could come into an interesting option to reduce the costs of interplanetary cargo transport.
If you can then refuel life support in rockets going to Mars and beyond, as well as fuel using lunar resources, you've then reduced the mass you need to lift off this planet. So it becomes an enabling asset not only for lunar exploration, but solar system exploration.
In the near future, the moon will become a key platform providing raw materials to space-based construction facilities. Construction in space, as well as manufacturing and other industrial processes, will increase considerably as zero gravity will make these kinds of processes much easier and safer.
It will make sense to move manufacturing off the surface of the Earth. And as Jeff Bezos says, all the heavy manufacturing will be done in space, and the surface of the Earth will be zoned for light industrial and habitation.
To reduce the cost of transport, the moon could store propellants produced from lunar water at one or several depots between the Earth and the moon to resupply rockets or satellites in Earth orbit. We know that water is a key resource as it can be used to produce rocket propellant and also to produce oxygen, absolutely necessary for colonization and life support. After having analyzed all the key points to be considered when building a future lunar colony, such as the location of the colony, the energy source, transportation, and the economic development of that settlement, we can undoubtedly consider that the building of a lunar base would be one of the greatest technological challenges the humankind has ever faced. Despite the huge difficulty that a lunar base brings with it, there are already some proposed projects in the near future by several public institutions and private companies. The first one was the Lunar Reconnaissance Orbiter, a NASA robotic probe launched in June 2009, and which is currently in orbit around the moon. It has scanned and mapped the lunar surface in very great detail. It has identified safe landing locations, searched for potential resources, analyzed the environmental radiation, and tested new technologies. While the U.S. currently has no firm plans to return to the moon, the European Space Agency, Russia, and China have all expressed interest in building a base there. In fact, the ESA, the European Space Agency, has designed an ambitious plan to settle on the moon in the near future. The Moon Village. It was announced by ESA Director General Jan Warmer in April 2015 during the Space Symposium in Colorado Springs, USA.
Moon Village is an open concept with free and open access for each and everyone, be it industry, be it the public sector. It is open for robotic activities, it's open for human activities.
The Moon Village is intended not only for scientific and technological activities, but also for activities based on exploiting resources or even tourism.
This is the idea of the Moon Village concept. And I can tell you that now already a lot of different entities worldwide, private and public entities, are interested and bringing different parts, very different parts into this idea. And I'm very happy that now also some entities like Blue Origin, Jeff Bezos, but also Elon Musk are announcing that they are interested to go there.
It is clear that in the future, humans will take part in crewed flights farther into the solar system. So the Moon Village could also act as the perfect springboard and testing ground with that objective in mind.
I believe that the Moon Village is already in its development phase, and it's only a question of a month or let's say 1 or 2 years that we really see hardware on the Moon belonging to the Moon Village.
The Moon Village would be a first step in the future exploration of Mars, as it would also act as a pit stop. At the beginning, there would be just robots, rovers, and huge 3D printers that should build the modules and habitat where the first astronauts would live in. In addition to the Moon Village, there are other projects led by other space agencies that intend to go back to the Moon in the near future. The China National Space Administration has commenced the Chang program for exploring the Moon to investigate the prospect of lunar mining, specifically for mining isotope helium-3 for use as an energy source on Earth. The Russian Federal Space Agency Roscosmos has planned a fully robotic lunar base called Lunar Polygon. The project is planned for the second half of the 2020s. Scientists hope that in the near future, we will witness the creation of the first lunar base for human beings. What may become a reality much sooner is tourism on the Moon. Some space tourism startup companies are planning to offer tours on or around the Moon in the near future.
We do believe that the first really big industry in space is going to be space adventure travel. And so people on vacation will be traveling from place to place in space, and we'll be providing the propellant so they can get to the space hotel and back.
Some individual companies as SpaceX, Virgin Galactic, or Space Adventures estimate that lunar tourism will be a reality sometime between 2020 and 2043. The company Space Adventures has announced plans to take 2 tourists to within 100 kilometers of the lunar surface using a Soyuz spacecraft piloted by a professional cosmonaut. In these future luxury tourist trips, exotic attractions might include the view of the far side of the Moon, which can't be seen from Earth, or the view of the Earth rising and setting against the lunar horizon. The interest of several private companies in space exploration is already a fact. The private sector is already working to begin a new era of space exploration.
We should return to the Moon as a stepping stone to Mars, but that it should be done commercially with public-private partnerships. Like, we do not need a large government program like Apollo that focuses simply on having human beings walking around on the Moon. That instead, we need to focus on developing lunar resources to enable eventual trips to Mars.
This collaboration between private companies and public institutions will soon produce great results in the adventure of the colonization of the Moon, to later expand to Mars, the asteroids, and other places.
That brings up the next major development in human history. And that is, for the first time, we have extremely wealthy technological entrepreneurs that want to move the needle of history. This hasn't been the case since the late 19th century and early 20th century that led to the massive industrialization and improvement in wealth all around the world in the 20th century.
This might be the first step of a new era. An era in which the Earth would no longer be our only home. Since human beings first ventured into space, they have dreamed of being able to live on another planet. Among all the planets of the solar system, there is one that is considered one of the best targets for possible human colonization: Mars. Its surface conditions and the presence of water on Mars make it the most hospitable planet in the solar system, other than Earth.
Mars is the most similar planet in terms of environmental circumstances, and it is the one that has the most resources to support human settlement.
Since the first close-up pictures of Mars by Mariner 4 in 1965, several NASA spacecraft voyages to the Red Planet have revealed a very familiar world.
If you look at the landscape on Mars, it looks like Australia or Arizona. It's a red-colored rocky desert with a lot of sand, and we have that in many places on the Earth.
Like Earth, Mars has polar ice caps and clouds in its atmosphere, seasonal weather patterns, dunes, mountains, canyons, and other recognizable features. This similarity of our neighbor planet to Earth have aroused the curiosity of the scientific community and kicked off a whole series of missions. Since the 1996 launching of the Mars Global Surveyor probe, NASA has developed the Mars Exploration Program. The goal of this program is to provide scientific information through a series of robotic orbiters, landers, and mobile laboratories. The first aim of that program was the program's science theme, Follow the Water, as the water is a key factor for life as we know it.
On Earth, there's a one-to-one connection between life and liquid water. And so instead of looking for life directly, NASA's doing with its partners the easier thing first, which is to look for water.
Several missions from 2001 to 2007 made progressive discoveries related to evidence of past and present water in the geologic record that make it possible to take the next steps toward finding evidence of life itself.
I want to find out if there is alien life there. And of course not big aliens, tiny little microbes, because it would be the first example of an alien form of life that we would find. And Mars is a good place to go look for that.
In 2011, NASA's Curiosity rover marked a transition between the themes of follow the water and seek signs of life. In addition to landing in a place with past evidence of water, Curiosity was seeking evidence of organics, the chemical building blocks of life. The ExoMars mission, a mission of the European Space Agency, ESA, in collaboration with NASA and NASA's Mars 2020, will finally try to discover if there is or has ever been life on Mars by searching for life itself in places identified as potential habitats. Finally, the third phase of the NASA's Mars Exploration Program is to prepare for human exploration.
And that already started. We are already planning the human exploration of Mars. I personally hope that it will happen in maybe the late 2030s.
This first manned mission to Mars will mean a milestone for humankind, as was the 1969 moon mission. When this happens, we will be able to say that our path to the colonization of Mars will have started. Human beings' curiosity and passion for exploring new worlds knows no limits. We always want to go beyond our boundaries. The origin of this impulse answers the need of the species to find new habitats that encourage its development. Now, our next frontier is beyond the Earth. Space colonization is the next logical link in our evolution as a species. Beyond the Earth, there are a huge number of resources that we could benefit from to keep growing.
This is a way that the human population can grow and thrive for thousands of years. We can clean up the biosphere, and humanity can expand into the solar system.
Space expansion and colonization might be the beginning of a new era for humankind to reach an unprecedented level of development. In addition, it could be the only way to avoid its destruction by external causes or even self-destruction. The choice could be, as H.G. Wells said, the universe or nothing. Climate change has become a serious threat to our civilization, and we are already starting to suffer its first consequences. Another threat, the danger of an asteroid impacting our planet, is real, and depending on the size of the asteroid, the consequences could be catastrophic.
We have the probability that a big asteroid might hit the Earth, like it was done in the past when the dinosaurs died out.
It's not likely to happen tomorrow or even in our lifetimes, but it is definitely going to happen sooner or later, and so it would be best if we were prepared for that.
A permanent base beyond the Earth would guarantee not just an alternative home in case of need, but also access to a huge number of resources out there. Mars, due to its characteristics, is considered one of the best possible places for that future permanent base off Earth. Other places like the Moon or the asteroids are also considered possible targets when it comes to taking the first steps toward becoming a multi-planetary civilization. Several private companies are developing projects to extract resources and rocket propellant from asteroids. What is more, the discovery of water on the Moon has led to the development of concepts such as the Moon Village, proposed by ESA, the European Space Agency, to carry out activities based on the exploitation of resources and scientific research. Nevertheless, to establish a permanent colony that may become a future home for human beings, Mars offers several advantages over the Moon or other places. Mars is bigger than the Moon and also has more resources that we could take advantage of. So it's better suited to improvements to turn it into the home for a self-sustaining civilization. While the Moon has no atmosphere at all, Mars has the advantage of having some atmosphere, composed primarily of carbon dioxide, about 96%, with other gases such as argon and nitrogen, which means we can grow plants just by compressing the atmosphere.
Mars has water, frozen as ice, and permafrost in the soil, but nevertheless there in large quantities. It has carbon dioxide, atmosphere, which is carbon and oxygen. It's what we need to make fuel. It's what we need to grow food. has nitrogen, which life also needs. These things are extremely rare or completely absent, for example, on the moon.
If we compare our own planet to Mars, they are surprisingly alike in many ways. Conditions on the surface of Mars are closer to the conditions on Earth in terms of temperature and atmospheric pressure than on any other planet or moon.
The temperatures get to about 20 centigrade in the daytime at the equator, which is entirely acceptable. At night, it can get very cold, but it's not difficult to shield against cold by wearing a heated spacesuit. As different as they are from Earth, the conditions on the surface of Mars are acceptable for human exploration and settlement.
Mars, in comparison to the Moon, has gravity more like Earth's. While the Moon's gravity is 1/6 of the Earth's, Mars is 1/3. Thanks to studies done at the International Space Station, the only available laboratory of zero gravity, we know that the lack of gravity is a health problem in the long term. We suppose that having gravity much closer to Earth's will be favorable to settling a colony. A lunar day is 28 Earth days, whereas the Mars day is 24.5 hours, almost identical to Earth's. Also, Mars is about half as far again from the Sun as Earth is, so it still has acceptable sunlight. All these similarities between the two planets have led NASA and several private companies to start development of projects for manned missions in the near future. The NASA program Journey to Mars has been gathering data for several years, leading to a radical increase in our knowledge of the Red Planet and paving the way for future human explorers. Furthermore, private initiatives by aerospace transport companies such as SpaceX work with a clear goal: to colonize Mars.
That could take several generations of crews. Maybe the first mission will just set up the greenhouse, and then the second mission might start growing a few plants, but experimentally, They might eat them, but they're not going to rely on them. And then maybe it's only with mission number 10 that we'll stop bringing food from the Earth, and we're really going to count on the food that we're growing on Mars.
To establish a permanent settlement on Mars won't just require a great deal of time, but will also mean huge technological challenges. Despite the surprising similarities to Earth, Mars is a hostile place for life.
As soon as you dig a little bit deeper, you realize that Mars is actually a very different planet compared to the Earth. It's actually lethal for human beings and most life forms that we know of on the Earth.
Human survival on Mars would require complex life support measures to be able to face the difficult conditions for life there.
The atmosphere is so thin that your blood would boil instantaneously. You would die of depressurization within seconds. If that did not kill you, well, the atmosphere is unbreathable. It's made of carbon dioxide. We need oxygen to breathe. That would kill you within minutes. If that did not kill you, then the dust on Mars is very fine-grained, very abrasive, cutting, and also toxic, chemically toxic. That will kill you in a matter of several weeks.
One possible suggestion for making Mars conditions acceptable for the human beings would be to transform the planet, adapting it to the needs of human life. A concept that has been called terraforming. Terraforming would be a process of planetary engineering that allows the creation of a local biosphere similar to Earth's, making the Red Planet a habitable place for human beings.
The idea is to transform Mars into the Earth. to make the atmosphere thicker, to make the planet warmer with a warmer climate, to over time transform the composition of the atmosphere from what it is today, CO2, carbon dioxide, into oxygen.
Many scientists using climate models and ecological theories conclude that the terraforming of Mars is a feasible idea. With present technology, the climate of Mars could be transformed, making it capable of supporting life. Mars is now very cold, overly dry, and its atmosphere of carbon dioxide is too thin to sustain life. But these parameters are interlinked, and the three of them can be altered by a combination of human intervention and biological changes. If we could warm Mars up, we would once again have a thick atmosphere and liquid oceans.
It takes a long time to progressively thicken the atmosphere, transform the climate into one that has that's warmer, and then over time change the chemistry of the atmosphere and make it oxygen-rich. We're not talking about decades, we're talking about many centuries, and it would be very expensive to do.
One strategy to warm Mars would be to use orbital mirrors placed in orbit around Mars to increase the total sun exposure it receives. This would direct sunlight onto the surface and could increase Mars's surface temperature directly.
What you have to do is heat up the surface using mirrors in space to get some of the trapped water ice and the carbon dioxide back into the atmosphere.
The other strategy to raise atmospheric temperature would to provoke an artificial greenhouse effect.
We know about gases that are much more powerful than carbon dioxide as greenhouse agents. And these are like fluorocarbon gases. And we could produce these artificially on Mars. On Earth, we do produce these things, we use them for refrigerants. On Mars, we would just release them into the atmosphere. If you warm the planet, it will come out of the soil and it will thicken the atmosphere with massive amounts of carbon dioxide, which we know is also a greenhouse gas. And that would turn the 10 centigrade rise into a 50 centigrade rise. Now, if you had that, then what you would have is really Earth-like temperatures on Mars. And it means that the water that is frozen into the Martian soil would melt and start to flow again.
Unfortunately, terraforming Mars is a solution that would require a great deal of time and a huge investment. Therefore, if we want to build a first permanent base there is no option other than to face the challenges involved for human beings to be able to live on Mars. One of the principal challenges among them is to protect against radiation. Radiation is a natural phenomenon that could cause severe damage to human beings by seriously affecting their DNA. The Martian surface has high levels of radiation due to its very thin atmosphere and lacks Earth's global magnetosphere. In addition to this, from time to time there are solar proton events that produce much higher doses of radiation.
Mars doesn't have a magnetic field, so galactic cosmic rays get through the thin atmosphere, solar flares, some of that gets through, and it can disrupt the DNA. So you need a habitat that shields the astronauts.
The Mars Odyssey spacecraft measured this cosmic radiation. It found that radiation levels in orbit above Mars are 2.5 times higher than at the International Space Station. A 3-year exposure to such levels would be close to the safety limits currently adopted by NASA. The effects on living organisms have been closely studied. Protons from cosmic radiation may cause twice as much serious damage to DNA as previously estimated, exposing astronauts to greater risk of cancer and other diseases. NASA is exploring a variety of alternative techniques and technologies, such as plasma deflector shields, to protect astronauts and spacecraft from radiation. Nevertheless, a 100% effective technique has not yet been developed. Another of the main challenges when it comes to sending manned missions to Mars is the huge per-person cost of the trip. In fact, it would not be at all feasible to create a self-sustaining civilization at its present cost. There are estimates, with the Apollo program as a reference, that calculate the present cost to be around $10 billion per person. It's essential to reduce this cost to undertake the building of a permanent base. This is precisely the goal set by SpaceX company.
SpaceX is a very impressive company. It was founded by an entrepreneur named Elon Musk, who really wanted to break the barriers and break the mold of the things that were stopping us from getting to Mars. And this includes both high-cost space launch, but also, frankly, the timidity of bureaucracy that's unwilling to accept the kind of risks that involve to just go for it.
According to Elon Musk, to make Mars trips possible on a large enough scale to create a self-sustaining city, the key factors are full reusability of rockets, refueling in orbit, propellant production on Mars, and choosing the right propellant. Full reusability is essential and truly the most difficult one.
That's very important. You know, up till now we've been throwing these rockets away after one flight. Imagine how expensive airplane flight would be if you threw it away after each flight. Boeing 747 seats 400 people, it costs $400 million. If they had to throw it away after each flight, an airplane ticket would be $1 million a flight.
The next goal would be the development of a system to refuel spaceships in orbit. The ships would have dry tanks on leaving the Earth. This would help to reduce the costs radically. Finally, the third factor that Elon Musk stresses is the ability to produce propellant on Mars so that spaceships can return to Earth, as well as choosing the right propellant. The surprising advances that SpaceX is making indicate that they will soon be able to reduce the costs of the trip considerably. But sending a manned mission to Mars would still mean solving very important questions, such as being able to make a safe landing.
Landing on Mars is tricky. First of all, you use an aeroshield to slow yourself down from orbital speeds to subsonic speeds, and then you pop a parachute, and that brings you down to a slow velocity, and then you have to then do the final landing with rockets.
The relatively strong gravity and the presence of aerodynamic effects makes it difficult to land heavy, crewed spacecraft with thrusters only, as was done with the Apollo moon landings. Yet the atmosphere is too thin for aerodynamic effects to be of much help in aerobraking and landing a large vehicle.
On Mars, you have to go through the atmosphere, and the atmosphere is not your friend. Right? So when you're coming in at high velocity, you have to shed a lot of that energy to slow down, so you have an aeroshield.
Landing piloted missions on Mars will require braking and landing systems different from anything used to land crewed spacecraft on the Moon or robotic missions on Mars.
The biggest payload we've landed on Mars has been about 1 metric ton. And for human missions, we need to have at least 10 metric tons landed, and preferably 20 or 30. So we're going to have to scale up.
The improvement of safe landing techniques on Mars is, then, a priority. The NASA's project Journey to Mars will investigate the entry, descent, and landing techniques needed to reach the Martian surface, which will guarantee the success of the first manned mission, scheduled for the 2030s. NASA has also already started to study closely what the best location for our first home on Mars would be. These should be locations of high scientific value that would also provide resources to allow human explorers to live on Mars. Local natural resources such as water and oxygen are crucial for humans to explore Mars. Liquid water might be obtained from 3 sources: ground ice, which would be buried or beneath the surface, the atmosphere, or hydrated minerals. Oxygen, by comparison, can be generated from the carbon dioxide that makes up most of Mars's atmosphere.
There's a lot of disagreement about where the Mars base should be. The poles have an advantage because there's water ice there. But the problem with the pole is it's dark for half a Martian year, which is, say, almost a full Earth year. So that leaves you either with the equator regions or the mid-latitudes. They both have something to argue. The equator is the warmest, varies the least with season. But if you go to mid-latitudes, you can get places that always have at least some sunlight all year long, but which have some water ice too. Not big fields of it like the pole, but nevertheless deposits of water ice that are readily accessible.
My favorite site, we call it Noctis Landing, and it's in the western end of Valles Marineris, which is this giant canyon that cuts the surface of Mars. I love this location because it's at the bottom of the canyons, but at the same time it's in an area that's very wide and very open, so that you can see the Earth easily in the sky and maintain communication.
Other possible places considered for a first location on Mars are paradoxically outside the planet. They are the small moons Phobos and Deimos.
The Martian moons are the sweet spot when it comes to a potential settlement site.
We should use Phobos and Deimos as targets. We should send first early crews just to make sure we can travel to Mars and come back safely, not to get too complicated. That will be already a fantastic adventure.
Both of them are much smaller than our moon. Phobos' mean diameter is 14 miles, and Deimos is just 7 miles, while our moon diameter is around 2,100 miles. The fact that they are much smaller means their gravity wells are almost non-existent. So landing and takeoff would be much easier than on the Martian surface.
The Martian moons are locked like our moon. They always keep the same face facing Mars. So if you wanted a place to explore Mars robotically, the best place to do that from is from the Mars-facing side of Deimos. Deimos is 20 times closer to Mars than our moon is to the Earth. So the round-trip light time to control things telerobotically is just a little more than 100 milliseconds.
These 2 little moons, so very close to the planet, might be used as a pit stop for the exploration and future colonization of Mars, and even for the colonization of the asteroids of the main asteroid belt, in orbit between Mars and Jupiter.
I think that they are very exciting places as a first step for humans to explore Mars. The very first missions to Mars, I think, should not try to land on Mars.
Once the location for our first settlement on Mars has been selected, the next step would be to decide which type of habitat to build so that the future inhabitants will have a safe place to live. The astronauts who walk on Mars for the first time may stay there for several months. As the Martian surface has extreme temperatures and the atmosphere is unable to protect them properly against radiation, they will need to have effective shielding against the hostile environment of Mars. NASA, with its program Journey to Mars, has started to explore different construction solutions. One of the most innovative concepts for sustainable habitation on the red planet is called Mars Ice Dome, which was designed for NASA by the company's Space Exploration Architecture and Clouds Architecture Office. This ice dome would be built using the most advanced 3D printing techniques. The Mars Ice Dome is a large inflatable structure surrounded by a shell of water ice. Water ice is an effective shielding material for galactic cosmic rays, and many areas of Mars have it in abundance just below the surface. So water ice is a great solution for building habitats on Mars. The Mars Ice Dome structure is lightweight, so it could be easily transported and deployed with robotics, then filled with water before the crew arrives. Another interesting aspect of the Mars Ice Dome is that the translucency of the ice washes the habitat with daylight, connecting the inhabitants to natural diurnal cycles and also lets them enjoy the views. Other construction solutions that involve burying the habitats before the crews arrive would require heavy robotic equipment that would need to be transported from Earth, which would make costs rise significantly. The Mars Ice Dome instead balances the need to provide protection from radiation without the drawbacks of an underground habitat. However, to make it possible for human beings to live in a hostile world like the Martian environment, we are going to need more than just a safe habitat. The colonization of Mars will also require a wide variety of equipment to provide services directly to humans and production equipment used to produce food, water, breathable oxygen, and energy. The first step will be to have life support technologies to recycle air, water, and waste in a closed recycling system and to utilize in situ resources. NASA is already providing advanced life support research and development of innovative technologies.
There are two ways to make the life support for a Martian habitat. You can either do biological or physical-chemical. The physical-chemical system is, frankly, simpler to implement and more reliable, and it's probably what we'll do first. What that does is it takes the water, the used water, and it purifies it and recycles it so you can recycle your water. That's the most important thing.
Nevertheless, for medium and long-duration missions, the life support system should be bioregenerative, a system that incorporates biological components in the synthesis, purification, and regeneration of basic life support commodities. It must be designed in such a way that the components are recycled or regenerated and don't need to be resupplied.
Which is using plants, and that's how the Earth does it. The way the Earth's life support system is that we breathe out water and carbon dioxide, and plants turn that into food and oxygen. And ultimately, that's what you're going to want. On a Martian settlement, we're going to want to set up greenhouses, and we will take the carbon dioxide that we breathe out and some of the water that we produce, and we will use it to grow plants. And they'll turn it back into oxygen and into food for the colonists to eat.
Those greenhouses will need a reliable source of energy that keep the functioning constantly. In fact, a source of energy for the general supply of the colony will be another key factor.
The energy source for growing plants on Mars is going to be Martian sunlight. The solar flux on Mars at the equator is about the same as that on Norway on Earth. If you go to Norway, there are forests, plants grow there, and it's enough. It's enough light to grow plants. Now, of course, the human colony needs more energy than that, just as we need more energy than just outdoor lighting in the daytime, which we use to grow our crops here. And you have basically two choices at the first, which is solar energy or nuclear energy.
The issue with the solar energy on Mars is that it is not totally reliable. A sandstorm could reduce solar energy for months, which could be fatal for the colony. For a permanent settlement there, we probably need to develop the Mars geothermal potential. But for a first base, the energy supply would be taken care of with just a small nuclear reactor. For any kind of colony that we are able to settle on Mars, we will need to study the different options of communication with Earth, made difficult because of the huge distance between the planets. NASA and ESA included communications relay equipment in several of the Mars orbiters, so Mars already has communication satellites. While these will eventually wear out, additional orbiters with communication relay capability are likely to be launched before any colonization expeditions are mounted. The one-way communication delay due to the speed of light depends on how far Mars is from the Earth. This delay makes real-time communication, such as telephone conversations or internet relay chat between Earth and Mars, highly impractical due to the long time lags involved.
To Mars, it can be as short as around 4 minutes, or as long as 20 minutes. Once in a while, if Mars goes behind the sun, you can't talk to Mars at all.
This blackout could be solved by using a future network of communication satellites, which would be a realistic solution for a full colonization program. There is no doubt that becoming an interplanetary species will require unprecedented technological and scientific effort. We know that to send a manned mission to a planet as distant as Mars will mean facing countless risks. Before the first human walks on Mars, a group of robotic exploration rovers such as Spirit, Opportunity, and Curiosity could be the outposts that pave the way and could help locate resources, such as groundwater or ice, that would be fundamental for the growth of the colony. The next step would be the progressive arrival of several robotic cargo missions to transport the equipment, habitats, and supplies. They should operate long before any manned mission. It's possible that this first settlement will be a scientific station to be able to do detailed in situ research into the Martian environment.
What I think we should be doing altogether, humanity, is to build an international research station at the surface of Mars, a bit like the International Space Station, but on the ground on Mars.
At present, several nations and organizations are developing long-term plans to send manned missions to Mars. NASA kicked off the Mars mission program with the launching and testing of the Orion multi-purpose crew vehicle in 2014. The Orion is the first manned spacecraft intended to go beyond the low Earth orbit into deep space since the Apollo program. It has two modules, the Launch and Splashdown Crew Delivery Vehicle, and the Deep Space Habitat Module, where the crew will live during the 16-month-long journey from Earth to Mars and back.
It's a good design. Now, it was designed to be bigger than Apollo, so the crew could be a little larger. It's designed to have a multi-purpose destination.
The first manned Mars mission is currently scheduled for the 2030s. On this pioneer mission, the astronauts will be able to orbit Mars for the first time ever and then return to Earth. Therefore, on this first mission, no walk on Martian soil is planned. In addition to NASA, other space agencies have different plans for the future exploration of Mars. ESA, the European Space Agency, through the Aurora program, has a long-term goal for the robotic and human exploration of Mars, with the hope of finding traces of life. it has already sent robotic probes like ExoMars in 2016 and plans to send the next probe in 2020. India, Japan, China, and Russia also have different robotic missions to explore Mars to be launched in the coming years. China and Russia plan to send humans to Mars in the 2040 to 2060 timeframe, but they are still long-term plans that could vary in the near future. Therefore, the only national space agency that has the clear goal of sending humans to the Red Planet is NASA, through its ambitious plan Journey to Mars for the 2030s. In 2015, NASA announced the launching of this enthralling plan, a program for human exploration and colonization of Mars. Journey to Mars that will culminate in a permanent settlement there. It has 3 different phases: Earth-reliant, Proving Ground, and Earth-independent. The first phase, the Earth-reliant exploration, started a few years ago and should last till 2020s. It's focused on research aboard the International Space Station to study the effects of the lack of gravity on the human body during long-duration space missions. The second phase, called Proving Ground, will test the capabilities needed by future Martian pioneers to live on Mars through several missions operating near the Moon. This phase will last till 2030. In the first of these missions, the Orion spacecraft will travel without astronauts thousands of miles beyond the Moon for 3 weeks. The next step will be a similar mission, but with astronauts inside the Orion. This crew will reach a milestone never achieved in the history of mankind. They will travel further from Earth than any humans have ever traveled before.
The Orion is bigger. That puts some challenges into it, but it'll be able to carry a little larger crew, and it has this multi-destination mission design for it. But again, to land anywhere still is going to require another component.
Also in the 2020s, they'll send astronauts on a year-long mission to test and verify survival in deep space as the final step before our arrival on Mars. Finally, the third stage, Earth Independent, has as its ultimate goal to send humans into low Mars orbit in the early 2030s. To reach this goal, they will need to test the techniques of entry, descent, and landing on the Martian surface, and analyze how to use the in-situ resources. Science missions are now very advanced, as there are plans for a new exploration rover for 2020 and a round-trip robotic demonstration mission that will bring samples of Martian soil to Earth in the late 2020s. In addition to different space agencies, interest in sending manned missions to the Red Planet, there are also several non-governmental organizations and private companies that have shown the clear intention of making the colonization of Mars a reality. One of the most proactive organizations is the Mars Society, which is dedicated to human exploration and settlement of Mars and has supported Mars analog research stations in Canada and the United States. Its president, Robert Zubrin, is a confirmed enthusiast of Mars colonization, as he is sure that nowadays technology is advanced enough to achieve it.
I think we could see Mars colonization in our time. We could see it much sooner than most people think. From a technical point of view, we're much closer today to being able to send humans to Mars than they were to being able to send men to the moon in the 1960s, and we were there 8 years after Kennedy's speech. Okay, if we had a president who made a similar bold and brave commitment as Kennedy and stuck with it, we could be on Mars by the end of his or her second term.
One of the most advanced private projects which is considering a self-sustaining human colony on Mars is the SpaceX project. The Space Exploration Technologies Corporation, the so-called SpaceX, is an American aerospace company founded in 2002 by Elon Musk, Tesla Motors CEO, and former PayPal entrepreneur, with the long-term goal of developing technologies that will allow a human settlement on the Red Planet to become a reality. Their ultimate aim would be to create a self-sustaining community, not just an outpost, that could grow into a city. To achieve it, Elon Musk states that an essential condition is to radically reduce the costs of the trip. As with the present costs, it would be totally impossible. According to Musk, the key factors to achieving lower costs would be the full reusability of the rockets, refueling in orbit, and propellant production on Mars.
SpaceX started by proving that they could develop space hardware at 1/10 the cost and 1/3 the time of the mainstream aerospace contractors.
SpaceX's plan is to create a Mars colony with a sustained population of 1 million people, which would mean 10,000 trips there with 100 people per trip in a time frame of about 40 to 100 years. The spaceship is designed with a crew cabin on top and a cargo compartment underneath, with capacity for 450 metric tons of cargo per trip. The duration of the trip would be about 80 days at the beginning, with the goal of reducing trip time to 30 days in the future. If all the plans are achieved, we would be witness to the arrival of the first crewed flight to Mars in about 10 years' time. Until that incredible milestone is reached, the goal is to send cargo from the very first trips to Mars from now on.
Musk might be able to do it. He's going to have to be lucky, okay? He's very brave, he's very determined, but this is a game where you have to do everything right and roll 7-11 or doubles.
Thanks to unstoppable technological advances, the settlement of a Mars colony is no longer the realm of science fiction, but a feasible reality. In the coming decades, we might be landing, working, and living on Mars. This could be just the beginning of the interplanetary expansion of the human being in the solar system. Maybe in a not-so-distant future, our home will be in a very distant place, in one of those remote space colonies.